Okay, there we go. Great. So this is going to be the full day, full afternoon Leadinggreen Associate workshop. Right now, I'm currently hosting a live webinar. We're doing it with about 25 people. Great turnout, best turnout yet. So that's nice. So thank you for giving me your full Saturday afternoon. Uh, to begin, I just want to say that it's a very fast-paced course. There's going to be a lot of material that might be completely brand new to you, and if not, some of it definitely will. So I just want to ease our way into it today with just going through why LEED exists, 10 minutes of why you're here, how this stuff's relevant to you, how it'll affect you in your career. So don't take any notes right now, and please just wait until we get into the meat of the material. I want to ease our way into the rest of the class that we have. So we should probably start by saying, what does LEED even stand for? And all LEED stands for is something called Leadership in Energy and Environmental Design. Simply put, LEED is used for us, the people, to rate what makes a green building actually green. And the reason why it was created was because early on, we kind of got sick and tired of people painting a building green and calling it sustainable. How does the public actually know what goes into a LEED or a green sustainable building? And that's why LEED exists. It's simply a standard for the public to trust that what we're living in, what we're renting, is actually sustainable and good for the environment, economy, and people. And that's why LEED was made, and that's why it still exists. Like a standard for your steel-toed boots or how clean a restaurant is, it's for us, the public, to trust. I like LEED a lot because it's legitimate. What I mean by that is we created it. So actual professionals who are in this field. So generally, we're not asking us the craziest amount to do for a LEED building, but it's still much better than the code. It's realistic. And when you make the commitment to go green, that happens right away, early on in the project, which is good because normally nobody knows what their design decisions and how it will affect the overall sustainability of the building before it's too late to make a lot of those changes. And LEED comes into play really early on in the project, which is good. But most importantly, it's marketable. They have spent tens of millions of dollars marketing LEED to the public. Frankly, if nobody knew what it was, who cares about it? But the public gets it. We know what it means, and so we're demanding it from our buildings more and more and more. So LEED is a point-based rating system, and I'm sure y'all have seen a few of these plaques in your life. It starts off with certified at 40, 50 silver, 60 gold, and the highest is platinum at 80 points. And there is 100 main points with 10 kind of bonus points, as I like to call them, 110 total to get your building up to one of those levels of certification. How do we get the points? There's a bunch of categories. Each category has a few prerequisites. Those are mandatory. You have to do all the prerequisites. Then once those are done, you can go for the credits, and that's where you get the points. And depending on how many credits determines your eventual level of award. These are the categories that y'all will memorize by the end of our afternoon together, I promise, so get comfortable. But really, why has LEED been so successful? You've probably heard about it before today's workshop. They have done a fantastic job at showing developers and owners that going green doesn't have to mean cash money green. And there's a lot of times where a LEED building doesn't cost much more or anything more than a conventional building next door. But usually it costs about 1 to 3 to 4% more on the initial construction cost, which doesn't seem like that much, but when you think about these $100 million buildings around town, 1 to 5 million, 1 to 3 million bucks extra, that seems like a lot to me. So why bother with LEED if it costs more? Well, there's a high return on our investment in 2 ways. The indirect way is our marketability at the bottom. So why do many universities and colleges only build LEED now? A lot of companies out there only build LEED buildings. Well, think about it. In 2020, when we're making our decisions, the environment's on the forefront of a lot of our minds. And it makes those companies and universities a lot more marketable. Maybe I'm more likely to go do business with you or go to university there because our environmental values align. And that matters more and more every year, it seems. That's kind of the indirect return. The real savings is our energy, and operations over time. And this chart kind of simplifies it for us. You see at the bottom here in red, that's the lowest cost just built to code, the bare minimum. Sure, it costs not that much at the beginning, but over time, you can see that slope go up. We're using more energy, more water, more maintenance. It's not the best built building, it requires more input. Whereas a green building, sure, initially costs a little more, but over time, we're less vulnerable to things like energy and water price fluctuations, simply because you're using less of the stuff. And maybe you have renewables on site, you could potentially sell back to the grid and recoup more of your investment. You guys ever seen this picture before? Throw some hands up, I'll get some claps, get some nods. I can see you. Hey, there we go, a few of us. It's called the triple bottom line, the 3 Ps, call it whatever you want, I don't care. It's kind of the basis of sustainability though today. And I'm going to refer back to it a lot, but pretty much we group our Earth into these 3 spheres. There's the planet environment, the people society, the profit economy side of the world. And I want our buildings to satisfy a lot of their wants and needs to get that sustainable building in our world. And I'll be referring back to this, but it's kind of the basis of what our goals are today. We just talked about the profit side, right? That was the high return on our investment. But what about us? We are in these buildings all day, every day, and we're demanding green buildings more and more because people are happier, they're healthier, more comfortable, productive, and that's where I want to spend my time. And frankly, if we are demanding green buildings and LEED buildings and companies don't meet what we, the market's demanding, those companies aren't doing too hot going forward. And you know, we're seeing that shift take place to a generational level. Like, look at high schools and elementary schools. They all have a component of sustainability now. I used to go to the Courtright Center for field trips. I remember that was a LEED Platinum home on there when I was a kid. Now it's there. Earth Day, Earth Hour. We have Earth Day coming right up next week. Who even knew about that thing 40 years ago? It's totally new to our culture. It's a big shift in our generation. But most importantly for us here today, it's a brand new job market. Look, we've had the blue collar industry, the white collar industry, and unfortunately I'm not wearing a green collared shirt, but we got the green collar industry here to stay, guys. It's growing rapidly. This is a great way to get our foot in the door. And it's not going anywhere, as I said, so might as well start today. And after all, it is our future, so we should probably not mess things up more than we have a bit already. And here's some cute babies over there. That is the people side of the triple bottom line. And look, we'll talk about it, the environment. Frankly, though, when you boil it all down, we only have one Earth, guys. Let's not destroy it. You know, let's preserve it for at least 1 or 2 more generations, I hope, hopefully more, by reducing greenhouse gas emissions, reducing our effect on climate change. And we'll talk a lot about that throughout the day. But one thing I like to point out, there's a lot of climate change deniers, and to them I say, look, even if we're not impacting the Earth's climate and CO2 say has no effect, which obviously it doesn't, why not just use less resources to do the same thing? You know, we're going to run out of them anyway. It's going to drive the cost up as demand increases and supply decreases. So regardless of climate change or not, you should just be more efficient with the Earth's resources, period, or we're going to run out. So a lot of people, I like to say that to the deniers out there. Okie dokie. Now, depending on where you are, there's often actual incentives, not as often as I'd like, to ease the extra financial burden of going green. Some examples I've seen in towns out there. Right now I'm in Toronto, and maybe if you build downtown, there's a structural incentive, for example. I'll let you build an extra story on your building if you go for green or go LEED. Why would I do that? Well, if you build a LEED building, your building's going to have less energy and less water needs. That's a less load on my infrastructure, and I want that as a city. And now you're saying, wait, you're letting me build and sell an extra floor I never even thought I was allowed to? You could recoup your initial cost right then and there. Some more common ones, though, are financial-based incentives. So in Toronto, where I'm at, there's a really good example. It's something called the Toronto Green Standard. So if you want to build in this city, And a lot of more cities are having these city standards. You have to meet the provincial or statewide code and also an additional code called the Toronto Green Standard. And so you have to meet the Toronto Green Standard Tier 1, which is almost just below a LEED certified quality of a building. And then there's another option called Tier 2, which you get about, the last project I worked on, a high percentage of your permitting fees back, and it was like in the hundreds of thousands of dollars. And when you reach that Toronto Green Standard Tier 2, you get the money back, and you're already above a LEED certified level building. So it's even easier. And one thing that often people don't think about is the more stringent your building code is, the higher quality building you're building, and the smaller it is to jump up to a LEED building. Whereas if it's not the best building code, you have to do a lot more to get up to LEED. And often people don't think about that, and I like to bring that up. And some non-financial ones, you know, a green building, build one in my neighborhood. We'll put you on the city's website as the greenest building in town to show off. Anyway, LEED is not alone. There's a lot of green building rating systems around the world. There's BREEAM in the UK, there's ENEV in Germany, BBC in France, Green Star in South Africa and Australia. Anyone ever seen this logo before? The Living Building Challenge, a few of us? A couple nods, a lot of shakes. So that's way harder than LEED. So living buildings, you should check them out. They have to be net zero energy, net zero water, treat their own wastewater. It's like the real true sustainability. I was lucky enough to just teach one at Georgia Tech. They just built this building called the Kendata building, and it's a living building, so net zero everything. And last summer, I couldn't believe it, they didn't need to turn their mechanical HVAC system on once. They didn't need their air conditioner. It was passively cooled in Atlanta. And you know, they're having a conference there with hundreds of people, and it was 75 degrees inside while it was 95 outside. It was wild that it actually worked. I had my doubts, but it's pretty cool to see. However, the reason why LEED is by far the most popular out of everything right now globally, it's realistic. It's not asking us the craziest amount to do, but it's still much better than our codes. And it's the same everywhere. So a LEED building is the same in every country, every province, state, city, and multinational companies like that because they can keep their building programs to a high quality, globally consistent. Anyway, I just wanted us to warm up with this brief intro to stress how far we really haven't come in the built environment. Buildings are not new. We've been building these things for thousands of years. But recently, we started relying on our fancy energy consuming devices out there. Well, why not take a look back at how we used to build before any of these devices were invented and take some of those naturally occurring passive techniques or variations of them that work with nature and incorporate them into our buildings today. And we could and we should, but we're not that good at it. Also, LEED is not the answer to the world's problems, but it's a good start for a couple big ones. And every few years, a new version comes out. We're on version 4 right now, which is still relatively updated. And as we continue to push the envelope, raise the bar, eventually the bar will be high enough, I think, to at least answer a couple big challenges we're facing today. Now, this afternoon, you got to focus on how much the values in LEED make sense. There's going to be a lot of time where you're staring at me saying, what is he talking about? That's just the most logical and sensible way to build buildings anyway. And you're right. But historically, we love taking shortcuts in our design and construction industries. And through incentivizing us with points in LEED, we're going to make sure we do it right the first time around. But everybody's got to work together to get that best building out of our investment. All right, everybody, that was our brief little intro. If you weren't paying attention, now is a wonderful time to start. We're going to talk about everything we need to know for the LEED Green Associate exam. So one thing I can't stress enough is you guys have these slides. So I sent them to you a few too many times, I think. So they're somewhere, if you don't have them with you, I promise you they're somewhere in your inbox. And if not, you can get them, I'm just typing it in the chat. You can get them at www.leadinggreen.com/slides. And you can get those right there. Thanks for that note, Christina, about the Montreal new code for their own buildings. I'm seeing more and more cities like New York City has Plan YC, and I'll interject with some of these newer ideas as we go forward today. As I mentioned, if you have any questions, guys, just throw it up in the chat. I'll get to it in a few minutes if I don't answer it already in class. Now, one thing I can't stress is, as I mentioned, you guys have these slides. I emailed them to you too many times. Please don't copy all this stuff down. That is the biggest waste of your time. I want you to absorb this stuff. You're here to try to understand this stuff. Every word I'm showing up here, you guys have verbatim. Now, by all means, take notes, highlight, do what works for you. But I want you to take something away from this, and that's understanding a lot more, okay? I'm hoping you all walk out of here with one, understanding why does LEED exist, which we touched on. What's its purpose? Two, next we're going to talk about who created it, who runs the show behind the whole LEED rating system. Three is going to be the majority of the class, the fun stuff of what goes into a LEED building to make it any more sustainable than the next door neighbor. And then our next step to pass the exam once we are all done. Now here's a brief little agenda. We just went through our intro over here. Now we're going to hop into the background of where LEED comes from, this basis. The majority of the class will be the categories. Now we're going to have a quick 5-minute bathroom break, about an hour in, and then a longer, about 20-minute break for if you want to grab a snack. And we'll probably be done. We'll be done about 7 o'clock. We'll be done the content maybe about 6:30, 6:45, and then I like to do a little 25-question practice exam. But if you got somewhere to be at 7, which I don't know, I don't, but you guys can obviously stay as long as you need. And at the question, I open up at the breaks, I open up the mics, and if you want to chat with me, I'm happy to discuss anything. Okay. Now, quickly, a little bit about me, how I got here, how I'm ending up doing this and meeting everybody. When I was a freshman, after I finished my first year studying at civil engineering, by the way, any civils here? You can use the applause. A couple civils. Any electrical engineers? Mechanicals? Got a couple mechanicals. Architects? I'm seeing you guys. Give me a hand. Environmental science? I think there was environmental science. Yeah, thank you. Some of you guys are listening. Interior design, there was a couple. Yeah, we got interior. What else do we have? Urban planners, I think. Landscape architects. Yeah, we got it all. And then there's construction as well. The nice part about LEED is how multidisciplinary it is. When you think about all the different people that go into not only building a building, but building cities, look, there's a lot of moving parts in this industry. And honestly, if you don't know what you want to focus on in the wide-ranging field, you might get exposed to a part of it that you had no idea was out there. And you might find your passion and pursue it in that direction. And that's kind of what happened to me. Quickly, how I got here. After my freshman year, I worked at this engineering firm. It's called Morrison Hershfield, and they were building the service centers, the en routes, if you're familiar with those on the 401 in Ontario. And they're really pretty, and they are all now LEED Silver certified, which I had no idea what that meant back in the day. But working on those buildings, I saw it was a way to define a green building, and I thought that was needed. I thought that was missing. And then I saw you could get accredited yourself by taking a couple exams, which I thought was an excellent way to get ahead in something I finally found interesting in this big industry. But back then, you needed actual LEED experience on a real project to take the exam. So I was just lucky to have that experience. And I had a very luxurious task on the project. I single-handedly designed all of their RV waste stations at those stops. If you know what that is, everybody, it's a hole in the ground. If you have an RV to dump its waste out, gross. But it's my claim to fame. I guess it's kind of sustainable if you think about it. Don't think about it, it's gross. But anyway, that was my experience. And I took the LEED exams, I passed them. I went back to university, and back then nobody knew what LEED was, not in my profs. So I was like, no bragging rights for me. But I was telling my friends about it, and they said, look, this is where we're going in the field. this is what I want to show in the industry. And this is what I'm interested in too. How do I get involved? Unfortunately, when you look around, a lot of these workshops, the materials are super broad, and some of them are like $1,000, and I don't know anyone with the time or money to do that if they're super weeks long. So I just started tutoring some friends, and eventually there was enough demand for me to host workshops like this. And I did that in Toronto, and a bunch of other universities said, hey, we want this too, help me out. And for the last 8 years now, I travel to about 60 universities each year to host this workshop. So I just stopped on March 7th when school started to close down. But at that point, I had 40 universities under my belt. So it's a pretty busy schedule, about 4 to 5 cities a week during the school year. And so far, 10,000 people have taken this workshop with me, and everybody who's followed my three steps after has passed on their first try. No pressure, guys, just don't mess that up. I also work as a LEED consultant. So that just means I help some owners and developers certify their buildings. So I'll try to bring in as many real life examples as I can to put a better spin on all this stuff here today. Okay, so that's enough about me. Don't need to hear anything more. There's two sides of LEED when we refer to it. So the one side we've seen is the buildings. Buildings get certified, and there's 4 levels of certification we talked about. When we refer to people, we get accredited. So buildings get certified, people get accredited. It's just 2 terms we like to use to separate buildings and people: LEED certification and accreditation. And the first level is why we're here, the Green Associate. It is the entry-level designation into this big field of sustainability. No matter if you're an electrical engineer, civil, any kind of engineer, an architect, an urban planner, if you have anything related to work done on a building or the land around it, this is going to help you out. And you know, a lot of people do just hop in here wanting a nice resume booster, which, don't get me wrong, it's a good one. And you can see more and more job descriptions are asking for you to have this knowledge. But I'll show you it's a lot more than a resume builder as we go on today. Look, those companies, why they want you to have this at least base LEED Green Associate is because when they bid on these projects in major cities especially, all these buildings owners are asking for their building to be LEED. And if I'm a company and I can say, hey, check it out, all my staff are LEED accredited, we know what we're doing, we all got at least the Green Associate, we're going to know how our job impacts the sustainability of the building. It's a lot easier for those projects and those teams to get the buildings and bid and get awarded the project. And it's not just architects and engineers, even like JP Morgan's whole real estate analyst division. They are trained because they want to know where all the money they're investing in their building is actually going to make it LEED certified. So it's super wide ranging. And it's a 2-hour exam. It's 100 multiple choice questions. It used to cost $250 for everyone, which for years I've been begging them to reduce for students. And finally, last year or 2 years ago, they did. Now it's only $100 for full-time students. And so that 8 years of begging pulled off. And I'll take full credit for that, but I'm sure I had nothing to do with it. But it's one nice obstacle avoided for students now. And folks, the real reason we're here, guys, I want you to pass this on your first time quickly. Pass rate's not that high, and I told you what this one is if you follow my steps, and that's honestly my goal, and that's why you're here as well. So the Green Associate, that is level 1, and so it is a prerequisite to level 2, the accredited professional. So the accredited professional, everybody, that is the one you'll eventually need if you're going to be in this industry for a while. Now, you can do it now or later, but eventually if you're going to be working directly with LEED buildings, it's expected. However, the Green Associate has to come first. So no matter what, this is the step 1. Now, some people have taken it combined, the Green Associate in one sitting back to back with the AP, and we're going to talk about that much later. But the AP is just more technical in nature. It's the points per credit, the percentages. And there's different specialties. So for example, I'm an AP BD&C and an AP O&M. For new buildings BD&C and for existing building retrofits. And then we'll talk about the rest in detail. And the fellow is just like this honorary thing. If we've done something special in the industry, we can get nominated for it. But that's all you need to know there. Okay. when we talk about, the level of detail I'm hoping y'all walk out of here understanding, if we were sitting here talking about the building code in your city, it might say, hey, if you're building a building in Toronto and it's this big, fine. Our zoning bylaw says you have to provide at least this many parking spaces. That's the law. That much parking spaces per square foot. Whereas the Green Associate, LEED says, and I want you to understand that LEED doesn't want you to build more parking than you have to. Just build the minimum required by law, no extra parking. The idea is, look, more parking, easier to drive alone. We don't want to encourage that. Whereas if we were studying for the AP, you'd have to know, don't exceed the minimum parking bylaw, beat the IT study by 20% for 1.4%, for 2.5% for carpool parking, this percent carpool parking for 2 points. It's way more detailed. That's the difference in kind of our levels of knowledge I'm expecting. We're here for the Green Associate today. All right. One thing I love about LEED and these exams is once you pass them forever. You never have to retake this exam, and it does get harder every few years. So get it out of the way now. It's the smartest thing you can do because it does increase in difficulty and it doesn't expire once you're done. Now you do have to maintain it, which is super cheap and easy. Every 2 years after you pass the actual exam, you pay $50 or $85 and submit 15 continuing ed hours. Those hours, I'll make a bet everybody here does those hours without even knowing you did them. If you're in school or you're working and your classes or experience has anything to do with sustainability or buildings, you describe what you've done and that's pretty much it. But after you pass, I follow up with you and I email you articles you can read online and different ways of getting these hours for free. So don't stress over that at all. And as I said, once you pass this thing, you're done. So get it out of the way now. You'll have it on your resume. You'll have it with you forever. It only gets harder, okay? You can also cross, I'm just answering Christina's question. So you can also cross different hours. A lot of hours that you're doing for maybe your architecture license or your engineering license can also count for those LEED 15C hours as well. So it's really easy to maintain is kind of what I'm getting at. Now, there's two sides of who created LEED. That's what we're going to talk about. We got the United States Green Building Council, and they're like the inventors of LEED. They decide what goes into the rating system, which is how we rate what makes a green building green. They also produce our reference guides, 800 wonderful pages, a great read. It's the Bible of LEED. It's exactly what you need to do one step at a time to meet the LEED criteria. And then there's this tool we'll talk about much later called LEED Online. It's where we submit everything. It's where you submit your proof, like your pictures and drawings and calculations that you actually did it right and built it properly. And somebody's got to review it and go through it as a third party. And the Green Business Certification Inc. are the third party reviewers. They go through everything and make sure it was done up to snuff. They also write our exams. They're the ones that create the exams that we eventually are going to take, the Green Associate and the APs. So folks, the way I like to remember these, I think of the USGBC as the creators of LEED and the GBCI kind of enforcing it and making sure we do it right. Now for our Canadians, we have the Canadian Green Building Council here as well. They do a lot of cool conferences and promotion and public advocacy. However, as I said, LEED is internationally consistent. Everyone in the world uses the USGBC's created LEED, and that's the one we're learning today because it's the one we use in Canada and around the world too. And if you're from another country, there's the Indian Green Building Council, the Chinese Green, there's a Green Building Council pretty much in every country, and then there's the World Green Building Council where they collaborate too. So pretty interesting stuff going on every year. But the USGBC does like to ask about themselves, so I have to talk about them for a minute. Their mission is to change the way that we build, and their vision is to make sure those changes are more sustainable. Go figure. There's kind of three guiding principles they run off of in LEED. LEED is voluntary. Like, you don't have to be here, and you don't have to build a LEED building out there. You can if you want. and you'll reap the benefits from building or studying LEED, and we'll talk about them as we go on throughout the day. But by no means is it the law. It's consensus-based in the sense that changes have to be voted on before new versions of LEED come into play and are initially created. So it's consensus-based by the industry and market-driven. Like, how are changes going to affect, yeah, sure, engineers, architects, but even like furniture manufacturers making products to be allowed to be installed in a green building? Like, that comes into play too as well. So it's really wide-ranging, all the industries that LEED impacts is what I'm getting at. And there's only two formally acceptable ways to refer to them, the US GBC and the US Green Building Council. I have no idea why some exams have asked that in the past, but if they ever do, there's an easy answer. Sorry, folks, I did not create the exam. Now, I mentioned LEED version 4 came out, still fairly new when it was enforced, and I just want to talk a little bit about that, how new versions come to life. The first step is we have to make up some pilot credits. These are new ideas. These are test credits. We're going to try these test credits out. If they work, we'll use them. If not, we'll change them or get rid of them. Then we are going to actually go through the LEED steering committee, get another approval, and then there's a big public comment. And that's every industry, all disciplines have their take and share their opinions on how the changes affect them in their industry. Then it's re-released, and if it's voted on by USGBC members and passes, it comes into play. Okay, so the only reason I'm telling you that is right now we are on LEED version 4. That is the current version of LEED. You might hear rumblings about LEED version 4.1 over the next year. You have to ignore anything you hear about that for now. If you're interested in it, go read about it, but not for the exam. Look, the exam is based on version 4. That's why we're learning version 4, and that's the one you're going to be seeing in real life industry for a few years to come, okay? So that's all we're going to look at. And even in real life, I have some LEED version 3 projects that are still on the go. So it's going to be the one you're seeing in industry for years to come, all right? 4. Okay, if you're ever lost tonight and today and saying, what does this have anything to do with LEED sustainability? Why are we talking about this? Take a breath, step back and say, how does this idea try to satisfy somebody somewhere in the people, planet, profit? Everything is going to come back to one of these 3 spheres in some way, loosely in one way or another. So just keep the people, planet, profit in our heads as we go through. All right, guys, on a big picture on this planet, one thing is for sure, as we know, our population is rising quickly. And the only thing going up even quicker is our demand for energy globally every year. How are we ever going to keep up? There's only 2 ways, right? You're either going to focus on creating more sources of it or using less of it. But think about it like this. For every 1 new kilowatt hour of energy our world needs, our people need, it is 3 to 100 times more expensive to create it rather than it is to say, wait, where do we use that 1 kilowatt hour? Let's just reduce our consumption by it. I'm saying it's way cheaper to reduce where we consume rather than building a new nuclear, a new coal plant, a new wind farm. We should maximize our reduction of consumption first. And if financially it makes way more sense to do that rather than producing more for now, might as well go for the biggest consumers, our big, beautiful buildings. Buildings consume up to 40% of our raw materials, up to 50% of our energy, up to 72% of our electricity, and a whopping 38% of our carbon dioxide emissions come from buildings. So if this is the largest fruit on our energy consumption tree, and economically, that consumption side makes the most sense to reduce before producing more, let's get started. And that is the whole purpose of today and of LEED, is reducing buildings' impact on the people and the planet. So why not try to start using good tools that have been around? We just stink at actually implementing them for our different industries. And I'm sure y'all have heard of life cycle assessment before. don't just look at one stage of a product or building's impact. You got to look at its whole life. How did we extract it, manufacture it, use it, end of life, where does it go, transport it? This is a much more realistic way of analyzing actual impacts of our products and buildings. And so I'm going to show you that LEED takes these underused but good tools that have been around and makes us use them sometimes without even knowing. All right, guys. We saw we're all here from very different backgrounds. So I do try and define any words I think you may not have heard of before. Now, if I don't do that well enough, please just use the chat function, ask away. I'm more than happy to help. If it's something way out of the scope of the course, I'll just say we'll talk about that at the end, just to keep us focused on this is an exam prep course and learning about the most efficient way to knock this thing out and understand everything we need to. So we'll start with a couple easy ones like a hard cost. That's the building of the building. That's the construction on site. Whereas soft cost, that's more on the design side. Permitting fees, consulting fees, inside the office. Value engineering is something we don't love in green buildings all the time. One thing we have mastered is making sure our buildings go over budget every time, it seems. What's the first thing that comes out of an over budget building, guys? It's the green items. Look, folks, you're not taking out the fire escape to reduce costs before your LED lights. No fire escape, you break the law, you don't meet the building code, you can't be a building. So unfortunately, when needing to cut costs, the first things to go are the green ones. And so controlling costs is a big part of LEED that we'll talk about today as well. And lastly, the systems thinking approach isn't what it sounds like. It's what system is around your building, like in a bustling downtown neighborhood or in rural upstate New York with nothing around you. Like, do you need, and analyzing things like how people will get to the building. Like, do you need to build all new roads and infrastructure and water and electrical systems? Because that infrastructure to connect people to that building could have a bigger impact than the building itself. And so thinking about what the system is you're building entering is around it and how it integrates, that's a huge part of LEED, which we'll see. Okay, here are the categories. And in the categories, there's a bunch of credits. And then the credits are worth points. Different credits are worth different amounts of points. So again, categories, lists of credits, credits are worth points. And the way LEED decided what to make each credit worth was loosely based on these 7 impact categories. So for example, everybody, the number one thing we're trying to get out of LEED is reversing our contribution to climate change. So we'll see that if credit A does that better than B, credit A will probably be worth more points, and we'll see that. We're also trying to enhance our human health and well-being on our planet, protect our water, our biodiversity, our other resources, generate a greener economy, and just overall social equity. Now, look, guys, you don't need to memorize these. They're really high-level, broad positives that we're trying to get out of our different credits and LEED itself. The reason why I'm sharing them with you, if you're staring and you're like, wait, why was that credit worth so much more than that one? What? Try to think back to these impact categories and you might see the light on why certain credits are valued as they are. And that's the only reason I'm showing this to you. All right, everybody. I'm sure a lot of you have seen a plaque on a LEED building. If you haven't, you'll notice it now. It's usually on the front window panel or behind the concierge's desk. How did it get there? That's this slide. First off, you have to register the project. Now listen, anybody can do that. You, me, a LEED AP, a Leadinggreen associate, it doesn't matter. And it does not mean you've actually really done much yet. It just means you're thinking about it. And usually the person who registers it is called the project administrator. And usually the project administrator is someone like me, a LEED or sustainability consultant. No matter where you are, Google LEED consulting in your city, and I'll bet you there is a ton of different companies that do this. Look, it's a big business now. There's a lot of owners, a lot of developers that are only building LEED and have been for years. So there's a lot of demand for a LEED consultant to help them on that path and make sure they're checking off all the right boxes and understanding what they actually need to do. And so that's kind of my job. I'm like this middleman between the project design team and builders, all actually building the building, and then the GBCI, the Green Business Certification Inc., who's going to review it. And I connect those two people through LEED Online. I'll show you it next slide, but it's our online submissions tool. And I chase everybody down. I say, owner, I need your signature for credit 1, architect, your drawing for 2, engineers, your calculations for 3, construction people, your pictures for 4, all your evidence. And I'll show you it next slide. This is a LEED scorecard. If you see this picture, it's in the textbook too. It's a long list of all the available LEED credits. And I usually use that with the owner. I say, hey, owner, what do you want to go for early on? Yep, check, 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 check. 50 points, LEED silver. Okay, tell the team we're going for LEED silver. It's always good to have a target right off the bat, and that is what helps us do so. Okay, here is the exciting interface of LEED Online. Thrilling stuff, I know. Pretty basic, guys. Who's on my team? That's this tab. What credits are we going for? What's the timeline of the project? Who works for the team? What are their credentials? What do I need from them for each credit? But everybody, this credit form is the most important part of our submissions. So every credit has one. And what it simply says is, hey, for credit 1, make sure you got documents X, Y, Z. You got them all perfect, ready to submit them. A credit form is a checklist to make sure we have all the documentation in order when we submit it through LEED Online. And LEED Online is our submissions tool to do so. Let me just look at the chat, see if we got any questions or thoughts right now. Okay. Great stuff. We have so many different disciplines here. Now, if something comes up in your head, just write it in the chat. Even if we already talked about it later, we'll revisit it later on. And so don't worry about if it's not on track. This is our next part of our presentation, which something I like LEED recognizing. Different buildings have totally different needs from a sustainable standpoint. And what LEED has done over the last 20 years is create new rating systems. So today we have 5 rating systems for different buildings. And this is the first rating system called the Building Design and Construction, or BD&C for short. And it's for new buildings. So look, 90% of all LEED buildings out there are under BD&C, mainly because this was the first one. And new buildings are the easiest to make green because you have absolute control over what you're doing from the start. Okay, so BD&C is the rating system. And then there's these market adaptations, these 8 bubbles, which are all very similar, except a new school has a few credits, have nothing to do with a new data center, and vice versa. So each of them have a few unique credits. Now, the most popular one by far is new construction, and that's for any new residential or new commercial building, which again is the most common type, so that's the most popular one. Then there's variations or adaptations for data centers, warehouses, hospitality, retail, healthcare, schools up to 12th grade mostly, and they're very similar, just a few credits that apply to a school or data center. The last one, corn shell, that guy's a little different. So one corn shell example I've worked in Toronto is like this 8-story office condo. And I was working for the developer. But the developer did not know who was going to buy and eventually occupy each floor. So they didn't want to put the wrong stuff inside for someone just to come in and replace new with new. So all we did was build the shell, the exterior walls, windows, roof, and floor, and the core hallways and lobbies and the HVAC to serve that shared area. So while we, the developer, just built the core and the shell, each tenant moving in has to go under IDC, interior design and construction. And that's for each tenant to individually fit out their space. So they're going to put their own furniture. They're going to pick their own lighting systems. They're going to pick part of their own HVAC systems. They're going to put everything that they want to into their space, flooring, ceilings. So while we, the developer, went for core and shell, each tenant is going to go, if they want to, for interior design and construction to fit out their space to a certain standard. So personally, um, I've worked on buildings where the core and shell is certified, and then I write like 100-page detailed kind of guide on how we built the core and shell and how each tenant can possibly take advantage of what we built for them. So usually the developer goes for core and shell if they don't know who the tenants are going to be, and each individual tenant goes for interior design and construction. But they don't have to, because sometimes they don't want to, or sometimes they can't. Like they're a strange space, like a lab. But I've also done them separately. Like this Gucci store in New York City, I got to just their tenant fit out. So that's one thing to note. They can be done separately, but usually they're done combined. The rating systems are not updated every year. They're updated with every new version. Last update was made for version 4, and that's already about 4 years ago now. Version 4.1 isn't making a lot of changes to that anyway, and it's not coming out yet. So there's not a specific framework for when they release new versions. It's not like it's every 5 years. It's kind of as the market needs it and is ready for it, to be honest. Question about an indoor farm. So usually that's a pretty unique building type, and you're probably going to go for the new construction one, which is just the most flexible for that one to go into. There's not a specific adaptation for farms yet, indoor urban farms, although they're cool and I think should be more a part of the future, not yet, just to answer your question there. This is our third one, guys. Operations and maintenance. And it's for existing buildings. And most people come into today's class and think to themselves, you know, this one's got to be the most popular. And I don't blame them, because when I look outside of the built environment, I say technically 100% of the built environment exists. It's there. We're living in it. And most of these buildings suck a ton of energy and leak even more out. What a huge potential for improvement. So why isn't this bigger? Well, simple. Look. Although there's a lot of existing buildings, it's tougher to make the argument to get, especially in like cities like Toronto and New York. I go to these old school developers and I say, hey, you really need to improve your lighting, your windows. By the way, if you do, you can save a bunch of energy. In turn, you'll save a bunch of money. Maybe you'll even save the world. Who knows? We'll see. And they say, Lauren, I'd love to, but I got a 95% occupancy rate, and everybody's paying my rents, even though they're probably crazy. Why would I change a thing and risk ruining this great thing I got going on? But if you can show them that tangible empirical evidence, just to start off with, say, $1 million LED lighting retrofit, ripping all their lights out, can save sometimes 500, 600 grand a year, depending on usage. Like that's a 2-year payback. Who's going to say no to something like that? And once they see the merit behind this, hopefully they'll begin to give you the rest of their building portfolio to do a more deep retrofit of. But it's a tougher argument to make, which is getting easier every year. Look, buildings are only getting older and leakier. Energy prices are going up. And as those really old school owners slowly die off, it'll be a little easier to make the existing building argument. How crude, I know, I'm sorry. Our fourth one is for homes. So this is a little bit of a newer one. It's a little different than the previous 3, and I'll explain why. Homes is only up for 3 stories for low rise, 8 stories for mid rise. Anything above that needs to go for new construction, the first one in B, D, and C. That's for residential huge condo towers generally is what I'm talking about. Now, the reason why this is a little different is because like Drake's house is like the next town over, and it is like 20,000 square feet for a family of, I don't know, 4 people. I don't care how efficient you claim that house is, it's not sustainable. You could put 10 families in that mansion. You could put 5 separate homes on that piece of land. Nobody needs that much space to live their daily life. So that's what I'm saying. Home is a little different. It says more build to what you need, and different credits is just applied to a smaller residential home or multi-unit small residential building. The bigger part of why they're different is they're not fully integrated into LEED Online. So listen, this trips people up. People think I'm this like LEED assessor guy, that I go from building to building, you know, I make sure they do it all right. So there's no such thing. Normally nobody physically comes on site. That's not a thing. Everything goes through LEED Online. So what happens is, usually it's something called a split review, where I design the building, we submit the designs and they're reviewed and they say, hey, you can expect to get LEED Gold. Then we build the actual thing and you submit what's called your as-built construction drawings and pictures. So if you don't know what your as-built are, that's what you actually built at the end of the whole process, approved by your local regulatory body. And listen, folks, if that doesn't represent what you actually built, there's way bigger problems than LEED that you have to worry about. So we don't need to worry about it in LEED. And that's what the GBCI reviews to make sure it's built properly and then rewards us with our certification plaque. That's how it usually happens. But for homes, it's a little newer. And so we have these 2 people physically come on site called a homes provider and a green rater, just to make sure we're doing the documentation properly and we're on the right path. Otherwise, no one physically comes on site is what I'm trying to get at here. Okay? Question about LEED becoming code. So elements of LEED have been adopted in certain codes, and that's going to be the process. I've also seen some cities, I think Boston used to have, you can either go for LEED or for our building code. So I don't see LEED becoming something universal like that, but I do see LEED kind of testing the market, which it does because it pushes the envelope, and then cities picking and choosing what they would have a big impact for them. And that's what I've seen as we go forward. Just to answer your question, Ian. Okay. So the home being LEED certified, that's a good question. So, you know, I'm gonna talk about the financial elements of buildings getting LEED certified and that plaque for investors. Getting a small single family home, it costs less to do. I'm not an expert in homes, to be frank with you. LEED focuses on buildings. There's also other ones that I like for homes, like Passive House and Net Zero are 2 cool ones that I like for homes, a little more than LEED, just to be honest with you guys. I've seen LEED for homes being used a lot for subdivisions, you know, cookie cutter homes, which in North America, obviously they're not sustainable, they're not mixed use usually, but we love them still for whatever reason. And so I say, look, if we're still going to build subdivisions, at least build them all to a high quality and get them LEED certified. So there's a lot of LEED certified and platinum homes. A link was just shared with us by Christina. Thank you. And so, but it does increase your value of your home. It makes it easier to sell when you want, and it's a nice tea topic when you invite someone over. What's that plaque? So that's my answer to your question about homes. So LEED for neighborhood development, everybody, is our 5th one. And look, guys, it's honestly where we're trying to go. A building can only do so much to contribute to the sustainability accomplishments and future of the world, but an entire community where you can live, work, play, go to school, it's walkable, you're sharing amenities, you're sharing infrastructure, that is going to have a big impact. However, it's a huge project. Think about it, like a new neighborhood or completely revamped. I was just in New York a couple months ago doing a tour of their Hudson Yards project. That's actually New York City's 5th neighborhood development. And it's a LEED Gold neighborhood. It's right in the heart of Manhattan. It's really cool. You've probably seen pictures of the weird honeycomb weird staircase thing, some tourist trap. But the rest of it's a lot more interesting, I promise. And Toronto, we just got one in the West Don Lands project. And look, I'm seeing more and more of these pop up. They're usually public-private partnerships. And that's where we're trying to go. They're just huge projects, which is why there's not that many of them. So those are the 5 rating systems in LEED version 4 today. There's also these two kind of special approaches. So LEED for campus, let's say your university is making a new campus in the town over, putting 5 new buildings there. Instead of applying 5 full separate projects, now you have 5 projects clogging up the systems to certify it. Now everybody's waiting behind you. You can apply in a one LEED campus umbrella. So those 5 projects in one project number. Just because they're probably similar and they're in the same place, so there's a lot of overlapping credits. It's to not clog it up. LEED for volume, that is the same idea, but the buildings have to be similar, but across different parts of the nation, let's say. So a great example, everybody, is Target. So Target, they moved into Canada 10 years ago, and the Canadians will remember, the Americans don't know that probably what happened. Target went bankrupt a few years ago, unfortunately, in Canada. I know we miss it. So initially, though, when they came into the country, they bought and built 124 stores nationwide, very similar, and they applied all of them in LEED volume and got a bunch of them certified to LEED silver right off the bat, which didn't work out for Target, but that's not LEED's fault. And all I gotta say is thanks, Target, for the extra LEED buildings. But it's just 2 ways to speed up the process for buildings in similar places or similar buildings overall. Thanks for that link. And so LEED buildings, in terms of affordability, it matters how you look at it. Your upfront costs are usually higher, but your ongoing costs are definitely lower. And a lot of subsidized housing projects that I've seen, and a lot of projects that are, you know, half unsubsidized and the other part of it is subsidized, a lot of them do tend to go for LEED buildings, as do a lot of public projects. Just to answer that question, Barb. This 40-60 rule. How do you know which one of the 5 rating systems your building should fit? So that's where this comes into play. LEED asks us to analyze the building, and if more than 60% of the gross floor area, guys, gross floor area is the square feet of each building's floor area, gross floor area. If more than 60% of that pertains to one of the 5 rating systems, that's the one to use. Now also listen, nobody uses that in real life. In real life, we decide. We're the project team. We know what suits the building best, and we're gonna pick it. And look, guys, this is super obvious. Like, it's either a new building or an existing building. Like, it's super obvious. The only time this rule comes into play is if you have an existing building and you're making an addition to that building. If the addition is bigger, 60% of the whole thing, if the addition is essentially bigger than the existing building, you're going to certify the whole thing under new construction. The only reason I'm mentioning this to you is because if they ask on the exam, how do you pick a rating system, please check off the 40-60 rule and then forget about it, because in real life, we decide, okay? So don't dwell on this. It's really not that crucial. All right. Here are the 4 levels of certification. Now, very seldomly are points at all asked on the exam. These ones you should definitely know. You should know that a certified building is 40, a silver is 50, gold is 60, and the highest is platinum at 80. Is there a trick we can remember? I don't know. Here, look, the S looks like a 5. And then -10 is 40 certified, plus 10. That's a horrible trick. Anyway, you figure it out. Those aren't too hard to remember. And there's 110 total points that we're going to talk about throughout the day. Okay. Now, that's the rest of today's class. All we're going to do is talk about how to get these points. That's the focus for the rest of the class, okay? And the first hurdle we have to hop over are these 3 things called minimum program requirements, or MPRs. These are 3 absolute bare minimums. They are worth no points. If you don't do one of them, you cannot be LEED certified, but they're super easy. All right, listen up, everybody. Number 1, you got to be permanently located on an existing land. What in the world? Existing land. So I teach this course in Dubai every few years, and they have these cool, huge artificial islands that come out of their coastline. I don't know how sustainable that was. Why are we building land into our seas and nature? And we got enough land already. So you can't build a LEED building on a piece of land that doesn't exist yet. You can't be doing the build out. It's what I'm saying, and ruining nature is the idea. That's the idea. So existing land and permanently located. Once you build the building, it can't move. No moving structures. Look, we'll see there's 16 points based on where the building is located. So no moving buildings is the idea. Stay there. That's one. Easy. These are easy. Two, you have to be a reasonable LEED boundary. You can't gerrymander. So, you know, if there's this contaminated swamp on our land, you can't just draw your building around your project boundary around it and not tell anybody that it's there. You're adjusting the boundary to make it easier to meet a credit. Just don't lie. And there's enough safeties and backstops to make sure you're proving what you're building on is actually what you're building on. So, but obviously someone did something bad and now that's a rule. So don't lie about what is on your site. Now the other part of this is a 2% gross floor building area up to site area ratio. So this is how efficiently you build on the land you own. In North America, guys, we're addicted. We love urban sprawl. We love using our land as inefficiently as possible. When we build to accommodate people moving into our cities, we like to build out and out and out and out where nobody was before. And when you build out to the middle of nowhere, well, now you need to connect these people with infrastructure, with water, with electrical systems. Now we got more cars on the road because no public transit is getting a stop out there in a low density area. We got enough cars. This 2% though is just the barest of minimums. So, you know, if our building here, if our building site over here is 100,000 square feet here of land, the building just has to be a measly 2,000 square feet on it. That's nothing. Like a small farm would meet that ratio. Think about the building or the home you're in right now. Like I'm in a 3-story building right now that's built on a lot line to lot line. So that's 1, 2, 300%. This is 2. This is the barest of minimums. All we're trying to say is don't build something super tiny and waste all that land. And we're going to see that a huge part of LEED, like 4 or 5 points, are all about building up and not out, and building where there are buildings already. And lastly, it has to be at least 1,000 square feet for LEED, BD, and C, and O&M. If it's smaller than that, I don't need LEED to tell me it's sustainable. It's obvious to me that it is sustainable. And LEED for homes doesn't have that requirement. It's a little different, as I mentioned. So guys, to recap, these 3 things are absolute bare minimums. They're worth no points, and they're super easy to comply with. You probably do them without even knowing you did them anyway. The next hurdle are also mandatory. Prerequisites are also mandatory and worth no points. If you miss a prerequisite in any part of today or any part of any category, you cannot be LEED certified. The reason why each category usually has a few is if I'm in Toronto where water is cheap and abundant, I might say, whatever, who cares about the water efficiency? I'm just going to focus on energy. That's where the money's at. You cannot do this in LEED. LEED is a whole building rating system. And for that reason, we have the prerequisites. They say, whoa, first off, you got to at least be 20% more water efficient than that prerequisite, 5% more energy efficient than that prerequisite, bring in this much fresh air in that. And then once you've met each prerequisite, you establish this minimum level of sustainability throughout all aspects of the building. And then you say, okay, LEED, I did it. I'm 20% more water efficient because you made me do it, but I did it and I get it. And now you're going to focus on what you actually want in your building in the credits. And these are the credits where you pick and choose. You pick what credit you want to go for depending on how many points it's up it's up for worth, how many points it's worth, how important the credit is to you, how hard it is to get, how much it's going to cost you to do extra. The credits are up to us, and it's where the points come in. The intent of the credit, guys, right there, that is the biggest part of the Green Associate. The principles behind LEED. I want us to walk away understanding, how does this credit result in a more sustainable building or world? Why did LEED choose to include it? Now, the requirements are a bit out of the scope of this class. That's what the AP focuses on, the points per credit, the percentage thresholds, the detailed calculations. However, I will talk a lot about them as we go forward, okay? But those are what focuses on the AP, and it's really what you're going to wrap your head around some of the harder credits. And then we'll talk about strategies on how to get those credits. Okay, we are literally going to take a 2-minute bathroom break right now. We're back. All right, the rest of the class today is all going to be about the credits and what we need to do to meet a LEED requirements to get LEED certified. The easiest way, everybody, for us to envision how LEED works is I need us to think about applying this to a brand new office building in a downtown core. We're going to use downtown New York City. All right. So that means we're using the BD&C rating system and new construction market adaptation. That was the most popular one, and it's the one the Green Associate is primarily based on. So new office, downtown core, that's what we're building today. All right, here's our first credit. It's kind of a category all on its own. It's a big part of LEED and sustainability. It's called the integrative design process or holistic design approach. So when you build a building today, there's an owner, an architect, 5 engineers, a general contractor, 20 subs, interior designer, landscape architect, urban planner, environmental scientist, so many stakeholders. And everybody's kind of saying, hey, this is my job. I'm getting paid for it. I'm going to focus on it alone, focused by myself. Do it the best I can. I don't want that in LEED. And LEED, well, I want people working together. I want collaboration. I want synergies between individual goals for the overall goals. So what we do is host something called a LEED charrette, which I'll share with you next slide. But an example, I'm a building envelope guy. So my focus is making a nice, tight, insulating exterior wall. Very exciting, I know. If you're the HVAC designer making all of our mechanical systems and we don't collaborate, I might have made my wall way too tight. And now you made your HVAC system more efficient than it ever had to be. That's over designing the building. That is not the cost-effective approach we want and need in LEED. So in LEED, we want to work together. And we do this by hosting this thing called a LEED charrette, which is a pre-design, a kickoff workshop. And so one I led recently, big boardroom, there were about 8 owner representatives there, and each design team had a couple people there too. And there was even some construction input as well from the construction consultant. And for like 5-6 hours, we brainstormed. What are the sustainable components we can include in the building? And well, we came up with a lot of good ideas. And I started making charts on the board of all these good sustainability ideas. And I slowly narrowed the priorities of the owners down to figure out what they wanted out of their eventual building. And that established what's called the owner's project requirements, which is simply a focus of what the owner wants out of the building. At the end of the day, folks, well, we're building the building for the owners. They're paying our bills. We better build it to what they want or we're not getting hired again. And we take that back to the office and make it into the basis of design, which is simply what the owner wants in a little more technical terminology. Okay? For the chat I'm focused on, I'm really trying to get a good grip for you to get a good grasp of a lot of these concepts, knowing the level of detail of what you need to memorize and whatnot, that is a lot for post-class study materials. That's going to be, you'll have a much better understanding of the level of detail once you try out a practice exam, and then you'll start to get a good feeling. But I'm going to wait until the end of the class to talk about that. So just hold on there, just to not ignore. I'm not ignoring your chat, I promise. Now, the reason why we try to get everybody involved early on is to avoid design changes needed midway through construction. Trust me when I tell you, it's very expensive to redesign a half-built building, and it happens all the time. If I can get everybody involved in the early design phases of the building, at least people around a table, understanding the individual design goals, we're going to be able to work together to get the overall goal in a more efficient and probably a more cost-efficient way too, or at least have contingency plans in place for obstacles that might come up down the road. And we just do this by having a little lead charrette. And all I do is I take meeting notes, I take meeting minutes, I get everybody to sign in, and I usually take a picture for good measure, and there's my point. If you get everybody involved early on, we're going to collaborate a lot more as we go forward. And that is our first credit, our first point. And on to location and transportation, our next bigger category that we're going to talk about here today. Okay. Location and transportation is a focus of where we build, what's around the building, and how people will eventually get there. There are no prerequisites in this category. It means you can skip the whole thing, which would be a bad idea, but sometimes you don't have a choice. This is the piece of land you're building on, deal with it. So that's why there's nothing mandatory in this, because sometimes it's out of your control. There are 16 points total in new construction, and the first of which is called sensitive land protection. Now, as a reminder, everybody, you do not need to know the point per credit. That is for the AP. What we need to know is why we're doing it, and also what the options are to get it, but not these specific little nitty-gritty details. So take a look. Why does this exist? Sensitive land protection. We want to avoid the development of a green field. If you don't know what that is, a green field is just something that's never been developed on. So don't ruin it. Protect it. And sensitive areas. Okay, so how do we get it? Let's take a look. Option 1 says pick a previously developed site. All right, everybody, where are we building our building? Downtown New York. That was easy. I don't know any undeveloped land in New York City, so wherever you pick, you get the point, right? But if you're building, say, in rural upstate New York and there's nothing there yet, how about avoiding these sensitive areas? Don't build on a prime farmland, near a floodplain, endangered species, wetland, body of water. There's simply better places to build. Pick one of them instead. However, listen, remember, even if you build on a piece of prime farmland, that's fine. This is 1 point. There are 110. You only need 40 for certified, 80 for platinum, right? This is 1 credit and it's worth 1 point. We are picking and choosing where to get the credits. So remember that. It's just the beginning. Okay. High priority site. So this is a site that is more challenging. Maybe there's an extra cost or a regulation and developers are kind of scared off. I don't want to, that's tougher. I don't want to do it. But maybe it's better for the world, the people, planet, profit, if they pick that tough site. And so the first example is a brownfield. So if you don't know what a brownfield is, it's a contaminated site. The best example are those decommissioned gas stations. You drive by them for decades. They just sit there polluting. I want someone to get in there, remediate that land, clean it up, and reuse it. Hopefully there's a government incentive. Hopefully the person you're buying it from will help you out doing it. Usually they have to. And now it's going to stop polluting the environment around it as well. And you get 3 points for taking that cost and challenge on. Option 2 is a priority designated site. Now this is different in different areas. LEED is piggybacking off of federal and state government agencies, which designate this neighborhood, that area is ripe for redevelopment, but developers are shying away because they don't know how quickly the building will appreciate in that unproven market. But no, I want people to get in there, redevelop, reinvigorate the economy, and I'll give you a point for assuming some risk in doing so. And lastly, it's historic district, developers' nightmares. There's always extra regulations in a historic area. But being historic, I'll bet you there's people in communities and infrastructure there already. So we say don't shy away because there's a couple extra regulations, but rather take them on and build with them and fit in. Don't avoid them because there's a couple aesthetic regulations. And as I mentioned, you don't need to know the points per credit. I do include them in the textbook though for your own knowledge. They will not come up on the exam. But as a rule of thumb, the harder the thing is to do, the more points you get. So the brownfield is by far the toughest, so that one's worth 3 points. Or this one's worth 1 point, or this one's worth 1 point. So you can get 1, 2, or 3 points on this. All right. Richard asks, does the charrette require a contractor? So there's no extra points. The best charrettes are the ones where you get the most people involved, but I've been in charrettes where it's design, bid, build, and you don't know who the general contractor is going to be. So we usually just bring like a construction consultant just to add anything that we want to for the class. Steve, for a LEED product, LEED doesn't approve products, but we're going to talk about that in an hour and a half in materials and resources, all about that. Like the gas station example was a brownfield. That was the contaminated site. Good questions. All right, everybody. Here's a biggie, surrounding density and diverse uses. It's a lot easier to just show this in a picture. It's talking about what's around the building. So look at this picture, guys. We're going to imagine that this building is our new site. And I want to measure the density in terms of building square feet up per acre of land. So I draw a 1/4 mile radius site around it. And then you add up the existing floor areas, all the gross floor areas in each of the existing buildings. And you take that big floor area amount and divide it by the acres of land on the ground. So think about what it's giving you. It's the amount of square feet up of buildings per acre of land. And the higher, that's just density. And the higher the density generally, the more points you're going to get. We're trying to decrease sprawl and discourage building out. The idea is, look, LEED says if there's a bunch of buildings already around you, there's a bunch of people in those buildings. And those people are serviced by infrastructure, they're serviced by amenities, and we can just hook into and share them with each other. So build where there are buildings instead of building out to the middle of nowhere. But like, what if you're in Wall Street or the financial district and there's 10 banks next door to you? I don't need 10 banks for my everyday life. I would rather have a diverse array of basic services. So instead of 10 banks, give me 1 bank and a restaurant and a grocery store, a pharmacy, a barbershop, a post office, a school, a park, all these diverse uses. And all we have to see here is if they're walkable. And LEED says, what LEED says is walkable is a 1/2 mile door-to-door unobstructed walking distance. It used to be measured as the crow flies like that, which never made any sense to me because I don't want people running across a freeway to get their groceries. So now it's a 1/2 mile door-to-door unobstructed walking distance. And those are the 3 location credits that we are talking about in this category. Richard is asking about which info, the square feet per floor area. Got it. So honestly, there's a lot of different ways to do it. There's a lot of times when you can go to the public records and just see what the building's total square footage is. If they're really stingy about it, I've even seen some buildings just estimate what their footprint is and how many floors there are, multiply the footprint by the but that's obviously not recommended. But yeah, that number is pretty easy to find, and the calculation is pretty easy. Good question though. Okay, transportation accounts for a whopping 33% of our greenhouse gases. Remember what buildings were? Buildings were 38%. Together, that's over 70% of our greenhouse gases. Like, that's pretty much everything. So the question I ask now, is there a way to not only reduce the building's emissions itself, but also emissions from transportation? And the answer is yes, for sure. Because where do we transport ourselves to and from? You usually start at building A and you end at building B. And how you go from building A to building AB is where all these emissions come from, building to building. So the next 4 credits have the exact same intent. The intent is to discourage you from driving alone in a big gas guzzler to our building. If everyone drove alone in a gas guzzler, that would be the worst way people could get to our building. And the only way we can discourage that is to make it easier to do something else, like ride public transit. That's the idea here. So the only way to make it easier is to locate within a quarter mile of a bus or streetcar, or a half mile of a bus, rapid transit, or subway stop. Look, guys, if your building is next to a subway stop, I'll bet your employee is going to try to get to the office using public transportation every day. If they're using public transportation daily, they're probably going to try to live near public transportation. If you're living and working near public transportation, you'll probably get rid of your car completely and just rely on that. That's the idea. But there's also a minimum trip count in version 4 now. If I watch one bus go by every hour, that is not helping my people get to where they need to be. I want multiple buses, multiple times passing by per hour to get my people where they actually need to go. And the way you document and show it is, here's an example I did in Toronto. So C is where my building is. Okay, that's where my building is. And then B and D are 2 bus stops within 400 meters. 400 meters, guys, is a quarter mile. LEED's American-based, so we're talking imperial units here because they're stuck on that for some reason. But in LEED, we accept both, but that's more worrisome for the AP. There's not a lot of those numbers asked, but whenever they come up, we have both in metric and imperial. And then I just went to the TTC, the public transportation website, and I downloaded and submitted the frequency of all of these different routes. And that's it. And one of the nicest thing about LEED that I like is a lot of the credits, I say to myself, you know, what is the easiest way I could possibly prove I meet this? And the easiest thing I thought about was taking a Google Map screenshot and showing them I'm close enough, check. And then I went to the public transport's website, I downloaded the schedule and I summarized it, check. And that's the official way to do it. And that's nice because it was the easiest way in my head to do it myself. So good question. If they change, Richard, you use what they are when you submit it. And a lot of the cases, if there's going to be like a new store going into your building, or there's going to be a new bus route where your building is, if it's operational within 2 years, you can include it in diverse uses, the last credit, or you can include that bus stop. So that's how that works. Greenways and pedestrian bridges to connect to neighborhoods. There's not one specific credit. Obviously, that would be lovely, and we were seeing some cool things like the High Line in Manhattan. If you're doing something yourself, you might be able to go for an innovative performance credit, but that's at the end of that's our last credit we'll talk about later on. Okay. If you guys got your webcams and you want to show up, that'd be great. I like to see you guys get entertained. I'd appreciate it. Entertained, learning. Bikes. Everybody likes bikes. I think this is like the highest rate of people biking ever on the planet. Now, 20 years ago when LEED came out, people loved to talk about LEED and say, oh yeah, LEED, whatever, put a bike rack on there, you got LEED gold. It's not the case. You got to do a little more for a LEED building. Even this credit alone is more detailed. You have to have short-term bike parking for visitors, long-term bike parking for your full-time occupants that's covered, and even showers. Like the last office I worked at here in Toronto, it had a big shower room. If I'm biking to work on a sunny, hot summer day, you better give me somewhere to freshen up before my long day at work, or me and nobody around me is going to be happy. And this is how a lot of LEED credits work, right? It says, look, everybody out there, I'm assuming, is the laziest they can be. And this is how I think designers can affect human behavior. I assume everyone's the laziest they can be out there. But if I make it just easy enough to ride a bike, or just easy enough to ride public transit, people will start to shift their behavior when the better thing to do is often the easier thing to do as well. So that's bikes. And our next one is parking. We got twice as many parking spots as people in the States, and I'm sure Canada is probably worse than that too. Boy, oh boy, we got a lot of parking. Don't build more than you have to. And we mentioned that early on today. Just build the minimum required by law, no extra parking. And give me some spaces nearest to the door, reserved for carpool parking. Because if there's somewhere to carpool, perfect. Then you have to enforce that and have a contract that says you will enforce it to increase the likelihood of people carpooling. And last is green vehicles. You don't need to be a Tesla to be a green vehicle considered, but that would be nice. Mine's currently floating somewhere in space. Same way to encourage it. Reserve parking for those vehicles, or offer a discounted rate. Like, how about offering offer free parking if you're driving a green vehicle? And LEED piggybacks off of ACEEE, and any car with a score of 45 plus is considered to be green, and that's, you know, light emitters, hybrids count as well. And you got to give me some EV charging stations. Look, if I'm going to work and I'm in the market for a car and I'm like seeing this open EV charging station that I could charge my car for free for all day when I'm at work, you know, maybe that'll impact my decision when in the market for a new car. And this is the EV charging station that we used for these 8 spaces. And that's transportation, discouraging people from driving alone in a gas-powered automobile. Okay, now listen to this credit. This is our last credit in this category, and it trips people up, but it's a lot simpler than people think about. So remember, neighborhood for development. That's what LEED ND stands for. I'm going to use the Hudson Yards project. This is a LEED Gold neighborhood. It's a huge area. And so let's say we go in there, we're a developer, we buy a piece of land in that big neighborhood, and we build a building in that neighborhood. Our building automatically gets 12 points because it's located in an already certified neighborhood. But you can't go for the last 7 credits. Like, if you're located in a LEED neighborhood development, gold area, the whole area has met this category. Like, LEED neighborhood development is this category expanded to a whole rating system. So what it's saying is, I'm trying to encourage developers to build within an already certified LEED neighborhood development. With that said, there's not that many yet. So this is a very forward-looking credit, and we're probably not going to do it. As more LEED neighborhood developments are created, hopefully it'll become more popular. And so very rarely are points asked on the exam, but you have to know these. I've seen them come up a few times. If you build in a LEED neighborhood development certified area, it's worth 8 points silver. Your building gets 10 gold, 12 platinum, 16. If I write in big red capitals, must know the numbers. Please know the numbers. I only do that a couple times, okay? But this credit is not that popular just yet. All right, guys. That was about where we build, what's around the building, how people get to the building. Here we have sustainable sites. What are we doing to the site itself? Now, these boxes up here, guys, are my naming convention. So this is my invention to memorize the credits. This is how you would memorize the credits if you ever go on to the AP, the accredited professional. Now, I'm not trying to confuse you by sharing them with you. Just if you're curious, I want to break it down. SS is the category, in this case, sustainable sites. C if it's a credit, P if it's a prerequisite, the name of it. The parenthesized D is if it's done mainly in the design phase, or C if it's done in the construction phase. These are the minimum and max points available in new construction, schools, and core and shell. And the Y is if there's an exemplary performance point. We'll talk about it at the end of the day. It's a bonus option. So I'm not trying to trip you up, but if I don't mention the point per credit, you can either look in the textbook or look at this slide. I break it down 1 point at a time, how much each credit is worth. But it will not come up on the Green Associate exam. That's what the AP focuses on. All right, everybody, here's our first prerequisite of the day. The first mandatory thing we need to do if we don't meet this prerequisite. No, if you don't meet this prerequisite, it's not like you just can't get the sustainable points, the sustainable sites points. You can't get any points, and the R is for required because prerequisites are required like this one. If you don't get this prerequisite, you can't do anything. Prerequisites are mandatory to establish a minimum level of sustainability in every category. And this one's not too bad to start. If you've been on a construction site before, you probably noticed it's a big mess, and there are trucks dragging dirt. There's chemicals spilling, rainwater washing it off, erosion there, sedimentation there. Keep your mess on site is all we ask you to do. Okay, keep it on your site. And so LEED was doing its own guidelines. They were like, all right, first off, do this, and then that. When they said, why are we doing this ourselves? There's a solid standard out there called the EPA's Construction General Permit, but a lot of people don't use it fully. Let's just use that one. Bingo, we're gonna start doing this. I like when LEED does this. They say, why should we reinvent the wheel? Let's piggyback off of these working, but generally underused standards and incorporate them into our own building. And we're gonna see LEED do this more and more. And this one tells you to do easy things like proper mulching techniques and control blankets. Here I took pictures of silt fencing around our neighbor's property, filters under the catch basins, and honestly, any half-decent construction manager would do this anyway. But now, well, you have to for the lazy bad ones if you want to go for LEED. And that's our only prerequisite. Keep your mess on site during construction. Done. Into our next credit, the easiest credit in the whole ballgame, in my opinion. LEED says, I want to know, you need to show me that you understand and comprehend the details of your site so you can use it to the best of its ability. And you need to prove that to me by describing it. That's it. Tell me about your site in detail. You've probably already done this in an environmental site assessment. It might be just a matter of rearranging the information, like topography. Is it hilly or flat? Where's the water streams, aquifer below, hydrology? Is there a building there already? Where's the wind blowing, the vegetation, the indigenous soils? You answer a few questions in each of those topics and you get one of the easiest points in the ball game. Done. Our next one is all about protecting or restoring our habitat. So remember we talked about what a green field was, never been developed. So let's look at this picture. Let's say that's a green field, never been developed. We say, hey, protect it. Save that area or a portion of that area. Don't pick that area to build on completely. Let it be, it's doing its own thing. And restore some land if it's already being developed on. So like if this parking lot here was already here, well, why not try to restore some of it to bring it back to its original form as a green field with native and adaptive and indigenous species? But where are you going to do that in downtown New York? Like, there's not a lot of room to play with. So they give you a financial option that says you can pay into a land trust, which you probably haven't heard of. They say, hey, if you can't fix your own site, we'll take your money and remediate a similar condition site within 100 miles. But it's not cheap. It's like 40 cents a square foot. So on that 100,000 square foot site, that's 40 grand for a point. So that's a lot. So you might just skip the credit. Next one's open space. Open space used to just mean this, a big vegetated area. That never made sense to me. I drive around to like these business parks around town and I see these huge rolling turf grass fields and I've never seen a single person actually use them. What a waste of land, I say. So the new definition, it has to be outdoor, usable, and accessible. And what I mean by that is put a nice courtyard here with a walking path to it and picnic tables. I've seen people do community gardens as an awesome way to create this open space. Even just benches around a pond is a way to encourage people to use the land. In Toronto, this building, it was a tight site and we looked up. So it's like a tiered terrace tower like this. And then on those terraces, I had planters, umbrellas, small green roof, benches, because that was a good option. And those are the first 3 quick credits in sustainable sites. The next 3 are a little more detailed. Wherever you're at, it seems that rain events are getting more and more extreme every year. That may be true, but what doesn't help is the amount of hardscapes we're generating and creating. A hardscape is just an impervious surface, a concrete and asphalt that water can't get through. And when we watch the water hit our site, it just flows off of it and we all forget about it, but we shouldn't forget about it because it takes a lot of energy. It takes a lot of our tax dollars to manage that rainwater, sometimes pump it and get it where it needs to go. So there's a few different options here to manage our own rainwater. And I say, why not just keep it on our site? And the easiest way, in my opinion, to do so is to dig a hole. Call it a dry pond, a bioretention pond. You can make it pretty if you want. And if you dig that hole and then slope your site cleverly around it, you can manage the rainwater on your own. Or you can build a cistern, which is a fancy word for a tank in the ground, collecting excess rainwater, storing it for later use in a dry spell. But boy, are there a lot of different methods to do so and strategies. I've seen some permeable pavements, especially in the southern states, which is asphalt lets water through, like we see here. Open grid pavement, I'm sure you all have seen this before. I've seen it on a lot of university campuses when I visit. It's half vegetated, half hardscape. It's usually very muddy and weedy. This is probably photoshopped here. Bioswales are fancy words for ditches at the side of the road, collecting excess rainwater. And the strategies are totally up to you. And one thing I can't believe I still hear in this day and age is designers say to me, Lauren, I don't want to go for LEED. Nobody's going to tell me how to design my building. And I say, what are you talking about? LEED says, try to manage this much rainwater on your site and pick any strategy to do it under the sun or under the clouds, I guess. Or don't, I don't care. Like it's 3 points, you leave it, like it's your call. So LEED doesn't only say you pick what credits you want to go for, it says you pick how to get those credits a lot of the time too. So it keeps the design open-ended. And even seasoned designers in 2020 often say otherwise. All right, our next one. Steve, we'll get to that question that you asked a little bit later. And the R, yeah, is required. Thank you for asking, just for the prerequisite. Now, we'll talk about different smart technologies we can use in the building in energy. Okay, you guys have probably heard of the heat island effect before. If you haven't, I'll tell you about it. Our downtown cores, our cities are often 2 to 10 degrees warmer in the summer than the rural and residential counterparts around us. The reason why this happens is because we live in a concrete, asphalt jungle of dark hardscapes. You can feel the ground. You can feel the sun beat on that ground in the daytime and it physically heats up. And then the sun goes down at nighttime, but as the heat radiates from that hot asphalt into the cool night sky, because our buildings are so close together in cities, and we also have wonderful pollutants like vehicle exhaust hanging out, The wind can't push all the hot air out, and before you know it, the sun comes back up and it shines on us and reheats the surface. So essentially what I'm saying is our cities don't cool off fully in the summertime. That increases our cooling loads, which is something we don't need in our cities. We're hot enough. SRI, solar reflectance index, is simply a scale of 0 being a dark black absorptive body to 100 being a bright white surface. It's how a surface rejects heat. Now, before we talk about mitigating the heat island effect, we have to talk about where the hardscapes are in the first place. And so first off, we're going to talk about the ground. Why don't you just shade the hardscapes on the ground? If you put trees along the sidewalks, the sun can't hit it, you solve the problem, you're done. Or on a spread out office or university campus, maybe put buildings closer together instead of way apart, so you just need less roads and sidewalks to connect everything. Or open grid pavement. Vegetation was good for rain, it's also good here. Or high SRI pavement, like a bright white concrete, not a dark black asphalt. That's all on the ground. How about the roof? That's a huge contributor. Don't use a classic black asphalt, maybe a bright white concrete or bright white metal cladding, or a vegetated roof. Green roofs, New York City has a green roof bylaw. Toronto's had a green roof bylaw where a portion of a new building over a certain size has to have a portion of it vegetated on the roof. And there's two types. There's extensive, which is just like planters on top, or intensive, which is like a 10-layered surface, pretty much trying to simulate a ground on your rooftop. And they're honestly really cool. And if you think about all of the different credits that they have synergies with, there's 5. So synergies means it can contribute to 5 different credits. A green roof can help with the heat island reduction, can help with rainwater management, protect or restore habitat, open space if you can access the roof for your occupants, and it saves you some energy with all those layers being a good insulator. But they're super expensive. However, they could be priceless, because if you're in New York City or downtown Toronto, there's often no other option to give your occupants vegetation. And so that might be priceless to you. I know it is to me. But they are expensive to build and maintain, but the technologies are getting a little bit better. And this is, I like adding some financial tidbits which aren't going to show up on the exam, but something that's often overlooked is a green roof costs, to build a green roof in New York City, costs the same amount to build a green roof in St. Louis. But as a representative relative cost, a green roof in New York is a lot less of a percentage of the asset's value versus St. Louis. So it doesn't feel like a green roof is that expensive in New York when your building is just way more expensive than a building in St. Louis. And that's just how it is. But that's often something that is overlooked, is the relative cost of going green is lower when you're A, in a city with a high building code requirement, and B, in a city with a high value building, which I like to add because it's something that's on my mind. And lastly is parking. We know how hot our surface level parking lots get over the span of a day. Put the parking under the building. If the sun can't hit it, it can't heat up. You solved it. Or stack it, like this cool parking garage, as long as it has a green roof or a high SRI roof on top. Or I saw this in LA a few months ago. Parking lots covered with a huge PV array, shade the hardscape, use the electricity for EV charging stations, 3 credits in 1, good idea. And look up at the sky tonight, everybody, and tell me all the beautiful stars you cannot see in your city because of light pollution, right? There's 2 kinds. There's lights that are inside that escape out of our windows, and there's lights outside to be safe walking home, find your car, whatnot. Stop shining light up into the sky or directly in line out the window. Like, just cover it. Concentrate it down instead of shining it up. I don't need light up there. I need light down here where I'm actually looking around. And by doing so, you'll reduce the light pollution. Maybe we'll see the stars. We'll save energy because we're not wasting up light. And we'll stop confusing the poor animals and thinking it's the star. Anyway, The way to show it, the way that LEED asks us to show it is pretty much using a lighting or energy model software, which we'll talk about in a bit. I want your boundary to prove your lumens or your light levels are around 0.1 or less. Essentially what it's saying is don't let light trespass off into your neighboring property. The whole, and there's different lighting allowances. Like downtown has a lot higher of a lighting allowance than a rural suburban area. And I'll show you how an energy model tries to help us here. And that's it for sustainable sites. We're going to do 2 more categories and then we'll take our break. Sound good? You don't really have a choice. Water efficiency is our next one. And before we get into it, I need to talk a lot about different types of water. The first one is potable water. Potable water is simply water that we have treated to a high enough quality that we can drink. That's it. It's drinkable water. Every single credit, there's only one intent in the entire category, and it's to use less potable water. Look, guys, if you can drink it, don't flush a toilet with it if you don't have to. Don't water a plant if you don't have to with potable water. Use less potable water is the whole goal. Black water is wastewater. That's urinals, toilets, kitchen sinks, and dishwashers. Usually if it touches human waste or food, it has to be treated. Gray water is in between those two. It's like reusable or non-potable. So rainwater is a good example. You can collect it and store it and use it later on for a dry spell for irrigation or your toilets. It's reusable but not drinkable. Processed water is like within the building system, so you don't necessarily see that. The easiest example we'll talk about is makeup water used in our cooling towers we'll get into. And purple pipe water, those in the north, I doubt you've heard of it. In the south, you have heard of it. Purple pipe water, it's treated black water. So it was wastewater. It's treated in a plant to a tertiary level, which is just below drinkable. And it's used for irrigation in a lot of public parks I've seen. Or like I've seen it used in the California desert for golf courses, where there shouldn't be golf courses anyway, but at least they're using treated black water is how I look at it. Okay, a few more terms. GPF is gallons per flush, how much goes down the drain when you flush a toilet. Gallons per minute is a flow rate out of your faucets or showers. Evapotranspiration is a very long word, and it's just the rate of loss of water through our plants' leaves from the ground. Okay, so these 3 are really important, so pay attention to me. Full-time equivalence is how we measure how many people are going to be occupying the building. So 1 FTE equals somebody spending 40 hours in a week in that building. Please just think of it as a full-time employee, right? A 40-hour work week. So if we were in a classroom together, normally I use this example, we're in a classroom together and there's 20 of us and we're all spending 4 hours together, that's 20 times 4, 80 people hours divided by 40 hours is 2. So together we would equal 2 full-time equivalents. Essentially, you try to add up all the people hours you're estimating people spending in your building in a week. You take that big number, you divide it by 40, and you get your FTEs. For us, please just think of it as how many full-time employees we're going to have in our office, all right? 1 FTE, 40 hours during a week. The estimate of people, full-time equivalents. Okay, the next one's really important. I keep on saying things like, you got to be 20% more water efficient, 5% more water efficient than what? Like I'm building a new building. What am I supposed to compare it to? So you need a baseline. This is our baseline. It's called the EPA Act, the Energy Policy Act, 92 or 05, same thing. And it's what we're going to compare our building's water consumption and reduce it. And I'll show you how to do a baseline calculation in a minute. And water sense label is just a standard for us to find water efficient flush and flow fixtures. So the way it works is like Energy Star is for energy efficient appliances, this makes it easier for us to find water efficient flush and flow fixtures. That's all that it is. The one water type I care about reducing is potable water use. On this planet, 70% of our surface is covered by the blue stuff called water, but only 1% of it is fresh, and only 1% of 1% is fresh and accessible to us. It's not like water will not run out, especially our fresh and potable water, so we should be more careful with how we use it. In the last 5 years, annually, 2 out of 3 of us on the planet at some point in the year were living in water stress conditions, which was not supposed to happen for a while. We looked to Cape Town, South Africa a couple of years ago. They literally ran out of water. One of the richest cities in Africa had no water. People just picked up and left. I remember a couple of my friends' families. It's crazy. Real climate migration happening today. Flint, Michigan, that water is still contaminated parts of it. California, are you out of their drought now? I don't know. It's been years. They're desalinating water in parts of the world, in parts of Southern California. Desalination's nutty. It is crazy. You are using a lot of energy and a lot of money. I got a better idea. Let's just use less. That should be the first plan of attack. Just conserve it. And so they were talking about ducting Great Lake water down to California. I can only imagine that having good impacts on the ecosystems as a whole. Just use less water. That's where I'd like to start. Okay, now in this category, we got 3 prerequisites with 3 corresponding credits. So each of these prerequisites got a credit that correlates. So there's like 3 pairs, think of it. So essentially how it works, and we'll see, is, hey, for the prerequisite, you gotta be this good. But if you wanna be better, I'll give you incremental points depending on the percentage you are better. All right, there's no calculations on the exam, everybody. But I think it's worthwhile to kind of show you how a calculation is done just for the water baseline, just for your own knowledge. So what we're going to do is imagine that we're following what the EPA Act's flush and flow rates are. Think of it as a conventional building, an old building, okay? Now, what we see here, we say are 200 full-time equivalents, right? 200 full-time equivalents, 100 women and 100 men. You assume it's half and half for this calculation. And we say women go to the toilet 3 times a day times by the EPA Act rate of 1.6, it's 4.8. Wash our hands 3 times, 2.2 gallons per minute times 30 seconds, that's 3.3. Do the same thing with the guys, toilet once, urinal twice, wash our hands same amount, hopefully. Add those 2 numbers together, and it says that we have 1,500 gallons per day. Okay? 1,500 gallons per day. That is the number to beat. Think about it, if we use the EPA Act's flush and flow rates, that's our number of water amount we'd use. And so look here, for the prerequisite, you have to be at least 20% reduced. Automatically, you have to meet that. And then every 5% better than that will get points in the credit. So remember, these are not my flush and flow rates. What did we actually use? And you plug them in. So let's say we use a dual flush toilet. That's only 1.0 gallons per flush. A waterless urinal or a urinal that only uses rainwater, that's 0 potable water usage. A low flow faucet, bring that number down to 2.8. And we see that our building says only 1,200 gallons compared to the 1,500 gallons, or 1,000 gallons compared to the 1,500. That's a 30+% improvement. And there you got the 2 points right there. And look, guys, in real life, the calculator they provide, they know what the EPA Act's flush and flow rates are. You plug in your FTEs and you plug in what your flush and flow rates and what kind of water it's using, and you submit your proof that you bought those actuals and you actually use them, and that's it. So that's how it works in real life. You compare your building's water usage, okay, to an EPA Act imaginary version of itself. Good for water? Couple nods, couple days confused. Good, good. Ah, there's some nods. I'll take it. That's indoor water use. How about outdoor? We love to water plants. Let's not. That's easy. Let's just use native and adaptive and indigenous species. Look, before this building is where I'm standing, there was vegetation here first. And it was doing its thing just fine. Let's use the same kind of vegetation. Because the same rain is falling and sun is shining around my building. And by doing that, we can do something called xeriscaping, which essentially is using no potable water, get your 2 points right there, reduced from the baseline. But if you need to irrigate, then, well, don't spray water above the ground. Most of it just evaporates or blows away, never gets to the root. Whereas drip irrigation delivers the water directly to the root where you need it to go, and that can save you almost 90% of the water usage. Where was I? I was at Vanderbilt in Nashville, and I was teaching, and it was a huge rainstorm, and I watched every sprinkler on the whole campus being on. Don't do that if it's raining. Have a demand meter that says, hey, we're good. Thank you. And non-potable, like collecting rainwater from the rooftop and using it to irrigate later on, maybe during a dry spell. Thank you guys in the chat. I know I was looking at the questions. It's a bit more of our high level water problems. So that's, I was gonna save that discussion for later, but thank you guys, Todd and Christina, for helping answer. So that was indoor water use reduction, and now we got outdoor water use reduction. And our next prerequisite is called building level water metering. So let's talk about building level water metering here. It's a new prerequisite, and it's really easy. LEED says, I want you to tell me how much water you use every month and share that data every 5 years. Guess what, guys? Somebody's metering your water usage because somebody is charging you for your water usage. So just ask your water provider to the meter we know that's there. And if they say no, we'll say whatever, we'll install our own right next to theirs downstream. Okay, so this is super duper easy to do. But what it alludes to is something interesting, I think. So listen, right now there is no recertification requirement for a LEED building. Once the building is certified, you get the plaque, it says what year, what version, and how high, and you're done. LEED operations and maintenance does have a recertification requirement every 5 years, but a new building does not yet. Look, guys, the oldest LEED building today is like 15, 16 years old. This is pretty new. And I'm telling you from real life experience, in reality, the owners are metering their water usage and energy usage very closely because they're the ones that paid all this money up front to save money over time. And if they're not getting their savings, they're going to find the problem. So in my experience, the owner is already measuring and metering to make sure they're getting the bang for the buck out of the systems. But what I think this alludes to is as LEED gets older and those version 1 buildings get older, there will be some kind of recertification requirement. But that's just a side note, and we'll see what happens. So this is easy, whole building level water metering. This credit is a little more advanced. It's metering 2 out of the 6 individual systems. So I want to know individually how much your irrigation uses: indoor plumbing, domestic hot water, boilers, reclaimed water, processed water. The idea of having a better idea of tracking where your water is going is if there's a leak, you can pinpoint it right away. Or you can say, whoa, my irrigation system uses that much. I got some extra money. I'm going to start improving it now. I personally haven't done this credit yet. Water schematics can get complicated very quickly on a building, requiring a lot of meters in a lot of different places, and those meters are kind of expensive. However, it's also new to version 4, so we'll see if it gets more popular. And those are 3 prerequisites and 3 corresponding credits. Ian, I don't fully understand that question. I'm going to talk about the resale values of and how it increases rent and sale premiums in a couple categories. So I'm going to hold off there because I have a big spiel on that. So those were 3 prerequisites with 3 corresponding credits. And this is the last credit. This is all by its loans himself. It's on its own, called cooling towers. Now listen, if you don't know what a cooling tower is or how it works, you do not need to know or understand it, but it's wonderful dinner conversation. So I'll tell you anyway. One way to cool air in buildings, guys, is we duct cold water through pipes. You blow air over it. You steal the cold temperature from the high thermal capacity of the water, and you take that temperature and you cool off air. That's it. When the water finishes its loop through the building, you hope it's hot because you've taken all of its cold temperature for the air. And all this does, the cooling tower that is it takes the hot water coming out of the building, sprays it over the large surface area, and has a big fan here providing evaporative cooling. It cools the water back down for the next loop. That's it. But, always a but, there's chemicals we need in this water. Those chemicals are needed to prevent scaling and buildup in the pipes around our building. Every loop, as I said, some water is evaporatively cooled, and as we lose more water, the chemicals get built up more and more until they're too concentrated, and you have to do what's called blowing down the water and replace it with new makeup water. This is usually the biggest potable water consumer in a building if you use a cooling tower. Whilst it's a very efficient way to cool buildings, it also uses a lot of potable water. So the easiest solution to fix this is to really analyze the initial chemical concentration in that water. And if you start off low enough, you can do maybe 10 or 15 loops instead of 2 or 3 before being blown down and replaced. Or just don't use potable water. You can use water collected from your rooftop or water from an air conditioning condensate, because every credit had one intent. The whole category is to try to use less potable water, and that is all for water. All right, guys, this is the most exciting one. Well, I like it the most because there's the most points available for it. Energy and atmosphere. Focused on where the energy comes from, and then once it's in the building, how do we use it? But first off, everybody, look at this chart. Canada, where I'm from, we're number 1. We're the best. We use the most kilowatts per person in the world. So we're the worst. Don't worry, though. The States is very close behind us. Look at how far ahead we are from the rest of the world. It is wild. Why is this the case? A few simple factors. Number 1, there's a lot of energy sources, and energy is relatively cheap in North America because of that. 2, it gets really cold here and really hot here, hotter elsewhere, colder elsewhere. Extreme loads, cheap energy, and a lot of people luckily having access to energy and electricity. Those 3 things makes us not scared to use a lot of energy, and we do, But how you should look at this, and I look at this every day waking up, is what a time to be alive and in this industry. This is the easiest time to improve because there's the biggest room for improvement. Like, lucky us. Let's get started. There's your Canadian optimism for you. Ice hockey rinks jab, solid Todd. I'll take it. Yeah, must be. In this category, we have 4 prerequisites with 4 credits that tag on to each other. So it's like water. There were like 3 pairs. There's 4 pairs here. So it's not as much as it looks like there is up here, okay? Now, if you've never heard of something called commissioning, you need to know about it. Commissioning is increasingly important, and what it's all about, if you've never heard of a commissioning agent or a commissioning authority, we touched on this. It's about getting a bang for your buck out of the systems you're paying for. So the owner hires this person called a commissioning agent over here as a third-party, unbiased set of eyes to oversee and make sure the systems will be planned, designed, installed, tested, and operated and maintained properly. because I've been on a lot of projects when a designer or a subcontractor has never seen this like very unique high performance system. And the commissioning agent is usually someone with a lot of on-site experience from a mechanical background, hands-on, and they're going to oversee and they're going to make sure that everybody actually does their job properly so that it will work properly. That's the whole end goal. We're trying to get a bang for our buck. If we're paying a bunch of money up front for these high performance systems, they better be operating at a high performance to reduce our ongoing operations costs. Now, these are the 4 systems you have to commission once: your heating, ventilation, air conditioning, and refrigeration system, your lighting and daylighting controls, your domestic hot water systems, and your renewable energy systems, if you have any on site. So we say commission them once, okay? Now look, if you already have a commissioning agent, which you have to, right? This is a prerequisite. You might as well get them to do the commissioning credit, which essentially is triple checking, right? So I'm asking you to commission 3 times. You're commissioning once before contractor submittals, again after 10 months of substantial completion, and on an ongoing basis. And arguably, even more importantly, for training. Train the building operator and the facility manager so they can continue to operate that building at the high level. Also, 2 of those 6 points are now for envelope commissioning. One thing in previous versions of LEED, a huge source of thermal bridging is a lot of subcontractors might make a mistake in the envelope. And if you got a thermal bridge, there goes all your savings. And so envelope commission, I told you I'm a building envelope guy. That's a new part of version 4, and I think I'm happy that it was included. Commissioning often costs about 40 to 50 grand per project. In 2020, I'll be honest, if you're not commissioning your building, it's a major building, you're way behind the construction curve. Most southern states in the US have commissioning requirements already. It's an absolute no-brainer. If you're paying so much money, as we said, for the high performance systems, you better make sure they're just going to be installed right so they work well. That's commissioning. Our next one is minimum energy performance with optimized energy performance, my favorite. So this is the exact same thing we just did for water. In water, we looked at the EPA Act as the baseline. In energy, we're looking at ASHRAE 90.1. That's our baseline. So maybe you've heard of ASHRAE, the American Society of Heating, Refrigeration, Air Conditioning Engineers. ASHRAE is a super important body. They create a lot of interesting standards and content and education, and they even have their own rating system, and LEED uses a bunch of their standards. ASHRAE 90.1 is the most important one we'll talk about today. You gotta know it. It's our energy baseline. Now, a side note, in Canada and in other countries, there are alternative compliance paths. So like we have our own version of ASHRAE called the NECB, the National Energy Code for Buildings. And you can use them interchangeably. You just have to beat it by a different percentage. I'll show you what I mean. It's internationally consistent. It results in the same level of efficiency, but you can use your own countries. However, listen, the exam we take is the same in every country worldwide, and it's based on the US standards. So you need to only know the American standards, not anything else. And ASHRAE is one of the ones you gotta know. There are 2 ways to show how we meet or beat it. Prescriptively is option 2. So this is if you're building, you go through and it's like, okay, you got X, Y, Z. All right, 5 points max. That is only done for buildings that can't be modeled. Anyone seen an energy modeling software before? Yeah, a few of us, awesome. Usually I ask what they are. You can type it in chat, what you've seen before. I'll name a few that are really popular today. eQuest or CanQuest in Canada. It's a free tool. You can download it. That's one really popular. EE4, that's a funny one we have in Canada. It's like DOS-based archaic system that I've used as well. It's hilarious. IES is really expensive and popular. It's not that, it's probably, I'm surprised it's popular. There's Energy Plus on Open Studio is very popular. And then there's like plugins for Revit called Ecotech. Rhino has a plugin called Diva and Ladybug. There's another plugin for Google SketchUp to learn on. Like there's so many out there. ResNet, there's so many. And they're all trying to do the same thing, which is estimate and analyze and try different systems out in the building to see which your building should use to optimize its energy consumption. Okay, guys, here's one I did in eQuest a long time ago. So this is a building in Toronto. First off, where is it? Is it in Toronto or is it in LA? Ecotech was the one for Revit, but this also integrates into Revit. Most of them, Energy Plus also integrates into Revit for Ian's question there. So where is it, LA or Toronto? Very different climates, unfortunately, for us here. How is the building oriented? What's the window to wall ratio? Like, build the architectural makeup of it. And then just like we did with water and the EPA Act, we're gonna do with energy and ASHRAE. And ASHRAE, or the NECB in this case, only know ASHRAE. ASHRAE says, hey, use this R value for the wall's tightness, roof, floors insulation, the windows U value, the lighting, boiling, heating, cooling systems efficiencies. And then you run the model with the guts that ASHRAE set it to use, and then it says we use this much energy. And that is the number to beat, okay? That is the number to beat. ASHRAE 90.1. And then you run hundreds of iterations. I'm not lying, hundreds. So in real life, guys, most of my colleagues are full-time energy modelers. This is all they do all day. Think about the room you're in. And think about just looking at your wall alone. If you got one window, the size of that window, what type of that window, what's the window to wall ratio, what's the lighting system, what kind of light, what kind of HVAC, like, there's an unlimited amount of ways you could design your room that affects its ultimate energy consumption. And when you find the right combination that's optimized and meets your occupants' demands and what they want, you plug in your design case, you run the design case compared to the baseline case, and you have a 5% reduction for mandatory prerequisite and up to 19 points for our 54% reduction. 19 points. That's halfway to a LEED certified building in one single credit. Look, guys, this is where we're reducing the most greenhouse gases. This is where we're reducing the most cost over time. That's why 2 pillars are hit, and that's why it's rewarded so heavily. Energy models often cost about 10 to 20 grand per project. In Toronto and more cities, a preliminary energy model is required for building permit, which isn't everywhere yet, but it will be. Look, guys, energy models are absolute no-brainers. Just think about buying a system, installing it, and seeing that it doesn't give you any return. This is the only way to play around with different systems and designs to actually see what your building will perform at without having to buy it and see it doesn't work in the first place. And then the third extra cost for LEED buildings are me, the LEED consultant, and all the documentation and the registration and certification fees. And that's usually about 40 to 50 grand. So those 3 things, listen, commissioning, modeling, and LEED consulting are around 100 grand. That 2 of those in 2020, you better be modeling and doing commissioning anyway. So we're talking about an extra 50 grand for a LEED plaque. That's a drop in a building budget's bucket. Where the actual costs come in for LEED buildings are the high performance systems you need to use to get up to that high level of performance. But as an owner, I'm not that afraid to pay for those systems, because those will actually give me a higher quality building that statistically appreciate faster, that have higher sale and rental premiums, that pass through savings to my occupants. So people out there love saying that, oh, LEED just costs and costs and costs money. It's really not true. A better building costs a little more money, I'll give you that. Once it's at that level though, getting it LEED certified really doesn't. Anyway, good talk. Our next one is building level energy metering. Okay, so this is the same thing we had in water. So in water, we measured how much water comes into the building. In this case, the two forms of energy coming into the building are going to be natural gas we use to heat, electricity for everything else. We're getting charged for those. Just ask for access to the meter or install our own. Easy. So this is easy. What we should do, and historically stink out in North America, is running our buildings. Running our buildings near their design case efficiency. And that's where our smart meters can help. I know someone asked about smart buildings. This is what a smart meter does, is it can take each end load energy usage, all that data, and analyze its usage to the hour, minute, or second. They're very accurate. And we ask them to be at least on your 10% or bigger parts of the building. And you should know what they are. Our biggest consumers by far are heating. Heating is the biggest consumer in buildings. Then usually cooling, then lighting, probably plug loads next. If you can see almost in real time where the energy is being used, you can analyze it, optimize it, and then plug it into what's called a building automation system to eventually run your building minute by minute as efficient as it can be. And that is our third prerequisite and credit. With the whole Internet of Things, IoT, there's been a lot of different products that have come to market that I've seen in the last decade that have been really easy to install, and I'm seeing that happen more and more. So that's nice to see that there's a variety as hardware has gotten a lot cheaper over time. Refrigerants. If you don't know what they are, they're usually liquids we use in our buildings, in our heat pumps, and they're good at carrying heat in or out of the building, okay? They're also historically horrible for the environment. ODP, ozone depleting potential. Refrigerants like to leak, and then they hang out in our ozone atmosphere, and they deplete our atmospheric ozone level. They also have a high global warming potential. If it's inefficient, you have to generate a lot more energy by potentially burning fossil fuels to get more heating cycles or cooling cycles. Anyway, the most popular ones have been chlorofluorocarbons in our past. I'm sure you all have heard of Freon in your life. We can thank Freon for being pretty much solely responsible for the holes up there in our ozone. It's banned in this country, Canada, North America. We've all signed on to the Montreal Protocol in '87, and since 2010, new buildings cannot use chlorofluorocarbons like Freon. HCFCs are on their way out. HFCs are still okay. They have no ODP, but a higher GWP. HFC 134A is a popular one that I use. Halocarbons are refrigerants in our for our fire suppression systems, if that comes up. There's also natural refrigerants. Think about air and water. You know, water can carry temperature in and out of the building too. A very neat thing we do in Toronto and Chicago does this too. It's called the N-Wave deep water cooling system. So we pump and draw very deep Lake Ontario water that's really cold in the summer, and we pump it through parts of the downtown core for cooling. It's pretty cool. Thanks. I don't know why, but there's always like 5 refrigerant questions. 5 refrigerant questions on the exam. And at the end of our textbook, I'll show you a little document that tells us everything we need to know about refrigerants. And Alex, ODP and GWP, they're both bad, but ODP directly depletes our ozone. For GWP, we can handle it if we start getting that energy to run the refrigerant throughout the building from a possible renewable or efficient source, whereas ODP you can't really do much about. What would be even better is the corresponding credit, which says no harmful refrigerants. Where I'm at in the Northeast, good luck. In the last week, I think I've watched temperatures go up and down 20 degrees in 12 hours. We got hot summers, we got cold winters. In between intraday, there's extreme. It's very unpredictable here. But I go to the Bay Area, San Francisco, the West Coast, moderate, consistent, predictable, always sweater weather, lucky you. I've seen buildings there naturally ventilate much easier, but here it's a lot harder to do. And so those were 4 prerequisites with 4 corresponding credits. And we have our last 3 credits. Focus on, guys, here. These are exciting ones, and then we'll take a break. 3 credits to go. First off, deals with this problem. This is the biggest problem I think we all face today. We like using energy at the exact same time. When we're all awake, we're all doing stuff, and that's consuming energy from the grid. And we can't predict how high our peak demand is going to get. So we have these reserve peaker plants on the sidelines. And how we use those peaker plants are we flip them on, right? We flip on the peaker plant when we get above our certain expected load. And the peaker plant is good for one reason. It has a quick startup and it can meet our demand quickly. They're also the most expensive way, polluting way, and the most inefficient way to generate energy. And we should never use them if we could avoid it. So a solution y'all are probably thinking about is generating, hey, a bunch of off-peak energy here. Good idea. Store it, save it, and use it on peak. Flattens out this curve. You solve the problem. You are totally right. You also are aware that energy storage is the biggest mystery to us. We can't figure an efficient and cost-effective way to do it. Every year, though, there's a new and cool technology. If you think of one, call me. We can become billionaires instantly if it works. But still, the leading way to do this, believe it or not, is the original way to do it. Pumping up water up a hill off peak and then running it down to turn a turbine. That's still the best way we got it. But we'll see. You know, there's cool battery systems going on. There's cool storage systems, and hopefully they'll come online. But until then, a way to deal with this peaking dilemma is called a demand response program, and it's gotten a lot more popular. Maybe you've heard of it. You gotta listen closely to how it works. I'll explain it slowly. Picture this, guys. I own this building, and you're my energy provider. We sign a contract that says, during the really hot days in August, when everybody in my town is cranking up the AC, peak, 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 I agree with you that you, my energy provider, can send a signal to my building called a demand response event. And if my building receives that signal, it automatically has to shed 10% of its energy demand. So my building has to react and say, I don't know, dim my lights, turn off a decorative feature I don't need. Up the temperature by 1 degree for 2 hours globally in the building, your people can be fine. And guess what, guys? Not only do I get 2 points for doing that, you pay me to do it. If I shed energy at the time when it's the most expensive for you to generate, you save a ton of money too, right? This is very counterintuitive. Like, can you think of another industry in the world where you, the provider, is paying me, the consumer, to use less of your product that you're selling? Like, whoa. But that just speaks to what I said early on today, that generating new energy is so much more expensive than reducing our current consumption. And this is financial proof of it. So I like this credit a lot because it makes a lot of sense and it's getting much more popular. A couple questions we have here. Radiant heat, that would be embedded into our energy model. That would hopefully save us some energy. So a lot of those technologies are going to be built into the energy model, which is why there's so much money there as well. Okay. Renewables. Everybody loves renewables. They're pretty and flashy. This is going to be our on-site renewable credit. So examples we have are going to be solar PV on your roof, wind maybe, tidal even, biomass, geothermal. And so the only interesting part about this, it's based on the dollar value of usable energy. Dollar value of usable energy. So look, we just talked about this. Sorry, energy storage is not the way to go. We want to use generated energy fast. So right now it's a sunny Saturday and I'm the only one in the building, let's say. There's PV on my roof generating energy, but nobody's here to use it. I don't want to store it for Monday for our occupants to come in. We got net metering or smart grids. Most of the time we have the ability to sell the electricity back to the grid and it meets the closest demand nearby or it comes back to us. The faster you use the generated energy, the more efficient. So if we say generate 10 grand worth of energy and my building uses 100 grand itself from the model, that 10% will get us 3 points. So it's just a dollar value. Here's a big PV array I worked on like 10 years ago before I started traveling, and now I look like this. Am I wearing the same shirt? Yes, I am. I am indeed. That's amazing. Still fits. Great. Perfect. Okay. Green power and carbon offsets are our next one. What if we are just tired of getting my energy from a fossil fuel or a natural gas plant? Maybe I'm even willing to pay an extra cent per kilowatt hour to get my energy from what's called a green E supplier. Green E is a standard that says, yep, that's an offsite wind farm, an offsite solar PV array. And now I'm diverting my fossil fuel-based investments towards renewable-based investments, hopefully getting them a higher chance of becoming more efficient, lowering the cost, as I see that in the chat. Richard told me that talking about the cost of solar in California, which is nice. It's coming down every year. Eventually it will outdo fossil fuels, I'd imagine. But as I said, I like to focus on reducing our consumption first. And this is this one is if you can directly get your renewable energy here. But what about in New York City, for example? There is no wind farm on New York Island, the Manhattan Island, rather. You can indirectly source your renewables by buying a REC, an REC. So renewable energy certificates, I'm going to talk about it quickly. It's not that important for the course. It's a tradable commodity. An REC is a tradable commodity. It's like energy you can trade. I'm going to explain it in a simple way. We're in New York. We want this wind power, but we're only next to a coal plant. That's our only option. Then there's this building in Oklahoma. They're next to coal and a wind farm, but they're just going to pay the cheap coal. So what I can do here is buy the REC, the renewable energy certificate. Essentially trades the commodity. It says, hey, Oklahoma, I'll pay the extra cent for you to stop using the coal and start using the wind. But you can still pay that cheap price for me to use the coal. So yes, guys, please don't overthink this. I know I'm not using the wind myself. You need to think about it on the grand scheme of things. I'm offsetting somebody somewhere who would have otherwise been using coal. That's how we got to think of it. You can buy it on the open energy market. I buy mine in Colorado, but that's all you need to know for us for this credit. Scope 2 emissions were what we just talked about reducing, off-site emissions from coal plants. But on-site, we also generate carbon. Okay, so on-site, we do generate carbon, and we buy carbon offsets to deal with those. Okay, carbon offsets, it's money. Take this money organization, plant a forest, or do a capture technique that reduces carbon levels equal to what I'm producing. Okay? We're going to take a break now. It's 5:40 on the dot. Thank you guys for being so attentive and sticking with me. We're running late, to be honest. I'm not going to be done the lecture until 7 for sure. There's been some good questions and good thoughts that come to mind. So the practice exam is going to be optional at the end. All right. The practice. Welcome back. This is the final stretch, everybody. So we are going to get into materials and resources. As a quick recap, so far we've done why LEED exists, who created it, the USGBC, what they're all about, the GBCI, LEED Online, and how we're going to submit all of our documentation. We talked about the 5 rating systems. Then we went into the integrated design process, working together from an early stage. Then we did location and transportation. where the building is, what's around it, how people will get to it, discouraging people driving alone, sustainable sites, what's on the site, how do we protect it, preserve it, restore it, rainwater, heat island, lighting, pollution reduction. Then we got into water, reducing potable water inside the building, outside the building, metering it, and cooling tower water, makeup water use. And then energy, commissioning, optimizing the efficiency of the building, metering it, refrigerants, demand meters, and then renewables on and off site. And now we're at materials and resources. So that was just a quick little recap. So for materials and resources, everybody, this is a focus of where the materials come from and how they're actually gonna be made. So again, materials and resources, all about where they come from and how those materials are actually made. Let's get into it with our first prerequisite called storage and collection of recyclables. If you want your occupants to recycle throughout the life of the building, make it easy for them to do just that. That's the whole idea here. Have a designated area to reduce the waste and recycle paper, cardboard, glass, plastics, metals, at least those 5 items, and 2 of these hazardous items. I don't care how it's done. It could be commingled in a big blue bin or have separated bins like I've seen on many campuses for different recyclable goods. The easier it is to recycle, the more likely people will do it. That's the whole idea. Our next prerequisite deals with important construction debris, because in some places in America, 40% of landfills are filled with construction waste. It's a lot. When you knock down an old building to build a new building, or even build a new building, there's a ton of waste. And here, this new prerequisite in version 4 is simply asking us to make a plan of what you're going to do with it. Identify your top 5 waste items and tell me what the diversion rates are away from the landfill. But that can be 0% here, meaning you can send everything to the landfill. I just want you to report it. The idea with this new prerequisite is we're forcing everybody to have a plan now. And if you're doing that already, you might as well divert at least 50% away from the landfill to 3 different streams. And I don't really care how you do it. Like, you can sell it to a reuse market. You can reuse it. You can recycle it. You can even donate it to Habitat for Humanity, even better. And the way to document it is by getting your poor lead intern like me way back in the day to add up all the cubic yards of wood and concrete and metals recycled, sum that up, and then here's how much went to the landfill. And we take the recycled amount divided by the total amount, and we get our percentage diverted down here, which was 80%. In 2020, nowadays, it is easy to get this done. Most waste haulers are set up for it. It's just a matter of actually making a contract to make sure they do it. Organic, so I was just asked about organic waste. I wish that was a requirement. You might be able to get an innovative performance about doing that. In cities like Toronto, where I'm at, it's mandatory. It's the law to compost. But there's a lot of places whose infrastructure doesn't have that allowed. But maybe later. No, I wasn't an intern for Leadinggreen. I was a couple different companies like Smith & Anderson Footprint and Provident Energy Management. Leadinggreen's my baby, so I started at the top. Building life cycle impact reduction is our next credit, and it's a big one. It's a tough one. So think about an existing building. You buy a site and there's an existing building on it. My question is, can you reuse parts of that building? For sure. And think about your potential cost savings. If you reduce the amount of money you have to pay to haul all this waste off and reduce the amount of brand new buildings you need to buy virgin materials, well, that's 2 savings in 1. But it's also really tough. The whole goal is reducing energy and waste associated with demolition. That's this credit. And the first option asks us to reuse a historic building. Guess what? If it's historic, you're probably mandated already to reuse parts of it anyway by law. So you make sure you reuse it and get the 5 points. An abandoned or blighted building like this, a derelict manufacturing plant, let's say, don't just knock it down all right away. Maybe parts of it are structurally intact and we can reuse those parts instead of demolishing it. Good idea. But the only option I've ever personally worked with, and the most popular option, is our third one. And that's all about reusing parts of that building, okay? Structurally reuse, we're looking at like building framing, load-bearing walls, roof, floors. Non-structurally, flooring, ceiling systems, doors. And based on the surface area of each of those items you can reuse, the higher the percentage of surface area reuse, the more points you get. Honestly, guys, this is the hardest credit in the whole thing. It is not easy to reuse parts of an old building and get all the things you want out of the new building. I've seen it done well a couple times, and it can be done right. You do just need a really good team right off the bat that actually want to get this done. The fourth option, you don't need to know too much about. It's an ISO standard for a life cycle assessment of how the building you are reusing or building new reduces 3 of these 6 impact categories. Those will not come up on the exam, but in general for life, you should just associate acidification, eutrophication, tropospheric ozone. Just know that those are bad things we don't like contributing to, but they won't show up. Okay? So Ian asked if it's just rehab. This is usually just for like using some of the bones of the building. And it's just focused on the actual materials, not like the mechanical systems. We never encourage reuse of windows and framing because they're usually leaky and the newer ones are better. And rarely is the existing HVAC, that doesn't come into play here. For existing building operation and maintenance, the other rating system, that might be a little more of the rehab-esque, but because we're focused on the new building, most of it is brand new, and this is just saving and reusing some of the materials to answer your question. Okay, we're gonna switch gears now. The next 3 credits are in their own kind of little bubble part of this category. So this one's all about the actual materials and how they're made. So the onus for these 3 credits is not solely focused on us, but the manufacturer themselves. First off, you need to know your base cost of your materials. So everybody, we're just going to say all of our materials cost $100,000. That's our number we're going to use for this example. That number only includes permanently installed materials, and MEP and furniture are optional. That stands for mechanical, electrical, plumbing. Why we don't want to include that sometimes is because, for example, one elevator in your building alone costs 60 grand, which is such a high percentage of our 100, it can really skew and mess up our results because it's such a high percentage. I'll show you what I mean in a minute. There's also a location valuation factor. So one thing we love doing in North America is chopping down a tree, shipping it halfway across the world to manufacture it into something, and then shipping it all the way back here to buy it and use it. The impacts from transportation emissions are immense. So this encourages us, by being a factor in the next 3 credits, to locally source, defined by extracting, manufacturing, and purchasing that material within 100 miles. So I'm in Toronto, I could chop down a tree in Buffalo, ship it to Rochester, the manufacturer, back to Hamilton to buy it, and then eventually use it here. And the materials will be worth twice their actual value in our calculations for these credits. Because when they're worth more as a percentage of the 100 grand, they'll be worth more points. I'll show you what I mean. All right. EPDs, maybe you've heard of them, maybe not. Environmental Product Declarations, EPDs. Okay? This is for the manufacturer to follow a certain way to make their item. It's an analysis from cradle to gate. So cradle refers to the point of extraction of the raw material we're going to use, and we follow it until the gate, which is the factory's gate. And in this frame of time and scope of time, I'm asking the manufacturer to tell me how they were able to reduce things like emissions to air, soil, water, waste generated, chemicals used. But this is not our responsibility. Our responsibility is actually selecting and buying 20 products from 5 manufacturers. So to answer your question, I told you in 2 hours I would. I think it was Steve. Are there LEED products? There's LEED certifies buildings. There are no LEED products. The way you market it, and why I get a lot of manufacturers in this class, is they want to be able to say, our product can help you achieve this LEED credit because we are certified under EPDs. So that's how the products work. And there's a volume option and then a cost option. So we just did the volume option, which was 20 products from 5 manufacturers. And now the cost option is 50% by cost of materials, or 50 grand of our materials, or only 25 if they're locally sourced, because that 25 grand would be worth 50 if it's locally sourced, double. The manufacturer has to show us in a report how they've reduced 3 of these same 6 impact categories, which once again, you do not need to memorize or know. They won't come up on the exam at all. So that was EPDs, our first manufacturer-related credit. Our second standard is called, so the cost factor, again, this is our base cost, say, of all of our materials. And 50% of our cost of worth of materials, so in this case, 50 grand worth of materials, have to show a report on how they reduce 3 of those 6 impact categories. Or only 25 grand if they're locally sourced, because then they'd be worth double in our calculation. No problem. Our next standard after EPDs is called Corporate Sustainability Reports, and this is focusing on the raw materials extraction. So did the wood come from a clear-cut forest, or was it selectively cut? Did we strip mine or remediate the mine after extraction? All we got to do, though, is buy 20 products from 5 manufacturers that were sustainably sourced as a raw material. But again, a cost option that says 25 grand, or again, 25% of our example, need to show in a way that they meet one of these 5 standards. So let's take a look at them quickly. Number 1 is extended producer responsibility. Okay, you're my battery supplier. I buy your batteries. I use them on my building equipment. Eventually they die, but we agreed you'll buy them back, recharge them, and sell them elsewhere. So you're extending the life of that battery. Good idea. Bio-based materials are encouraged, not including skin or hide. LEED uses FSC, which is Forestry Stewardship Council wood, or SFI, which is Sustainable Forestry Initiative. Those are the 2 woods that LEED considers to be sustainably forested. Materials reuse. Maybe the building next door or down the road is getting knocked down, and I can buy their doors and use them for my doors. Or recycled content, 2 kinds. Post-consumer is like the milk carton, finished, recycled, used. Pre-consumer is like excess or damaged goods from a factory, no longer used as, like, it's a mistake. But instead of throwing it out, repurpose them into something else. So these percentages, only 50% of pre-consumer recycled content can be counted the value of, which just shows that we'd actually prefer post-consumer recycled content in our products, because that was actually used as intended, whereas pre-consumer is more of an accident. And our final one is all about materials ingredients. So this is for both. It can be used for structures and furnishings as well, and surfaces. The only thing that the way that the credit language is it has to be a permanently installed material. So it's got to be staying in the building is the idea. That's to answer your question, Christina. So this credit made a lot of drama in LEED version 4. This whole category is pretty much being revamped from version 3 to 4. And the reason why this one made such a fuss is it really asked manufacturers to be more honest about the exact what they're putting in their products. And like if you ask them like plastic manufacturers, I don't know how much luck you'll have with them if they want to tell you more about their products' environmental impact. So this delayed LEED for like 2 years in version 4. And eventually the USGBC sat with the American Chemical Association, and they now have like 10 different standards here for the manufacturer to report what their ingredients are they're using. The idea is I want to know what I'm buying from them and putting in my building. You can optimize what you use, or rather don't use, or optimize the supply chain of that entire materials process. I only would like you to know green screen here and green label. Those are the two that I've seen come up. Just know that they deal with this, this credit is all I'm asking, okay? That's it for materials and resources. There's one credit that I've always shared with when I taught for the last 7 years, and boy, I can't imagine a time where it's going to be more relevant than now. For those watching the recordings, this is April 2020, an interesting time to be on the planet. And this credit is just for hospitals, healthcare. The reason why I'm sharing this with you is because I want you to understand that schools have a few unique credits, and then data centers, and then warehouses, and hospitals do. So this is just one for hospitals. And it's so relevant today, it's nuts. If you can design a hospital to be flexible over time, that would be great for things you don't even know are going to come up. So look, demographics change around that hospital. New technologies come in that a hospital needs to adapt. And as we see, new diseases come in, which really have to adapt hard and increase the ICU and do all these different things in the hospital. So maybe when you're building that hospital initially, don't build a full green roof, because you couldn't build on any of that if you needed to build up. Maybe oversized spaces and hallways, and you can rearrange stuff if you have modular furniture. Or you can even do something crazy like use the interstitial space between floors and redesign like this. So while you do not need to know these specific credits, I want you to understand that each of the adaptations in B, B, and C has a few unique ones that just pertain to its own building type. All right. If you break down a cost of a building, everybody, and you analyze the cost of everything, take a look at the energy cost per year. On average, you're maybe paying a couple bucks per square foot for the energy to run our office. Maybe we're paying 20 bucks per square foot to rent that out. But the people, you and me, if you summed up all the employees in that office, all their salaries and benefits, and took that big number and divided by the floor area, you'll see that we are paid over $300 per square foot per year in salaries and benefits. That is 10 times more than rent. That's 100 times more than the energy. What I'm getting at, folks, is we, the people, are the most expensive part of the building. And where we come into play in this whole sustainability conversation is indoor environmental quality. And this deals with, look, our comfort and our health. The USGBC even has its own a new rating system. Maybe you've heard of it, called WELL. I think we're a little, in my opinion, I think we're a little too far ahead. And I think that we need to get more adopters of LEED before taking the next step. But that's just my opinion. And this category does a pretty good job at taking care of us. This sounds crude, but like, we already commissioned the energy systems, which only cost $2 per square foot per year to run. The people are 100 times that amount. Let's commission the people if we can. Like, I want the highest quality of work at the best level of productivity you can get me if I'm paying you so much money to do it. And the only way we builders can help that happen is by having you happy, healthy, and a breathable indoor environment. That's the focus of this category. because we believe, believe it or not, we spend 90% of our life indoors, and I don't want to know what that number is right now, but it's higher. In normal times, we say 90%. Indoor pollutants are always higher than the outdoors, and we got to address that. A densely occupied space is a space that has 25 people in a 1,000 square foot area, if that word ever comes up. I'm sure the interior designers have heard of VOCs, volatile organic compounds. We do not like those. They are off-gassing pollutants in our paints and adhesives. They constantly pollute the indoor air quality. Bad. And there's different spaces. So like a classroom is like a regularly occupied space. We're in it. Whereas a bathroom or a mechanical room are not regularly occupied. We'll see that different spaces have different requirements as we go on. All right, here's our first prerequisite, everybody. Minimum indoor air quality performance. So during the, oh yes, thanks for seeing the new hospital wing in Montreal is, I think, LEED Gold or Platinum. Thanks for sharing that link. I was just there a couple months ago, funny enough. This is during the OPEC crisis back in the 70s, so energy prices went through the roof. And so back then, engineers said, expensive energy, let's just bring in less fresh air, because the less fresh air, the less we have to heat or cool. And they're right, you'll save money on that energy. And those buildings are awful. They're stuffy, they're polluted. I'm sure they're on your campus. They were on mine. So all this is saying is bring in enough fresh air. That's the focus. Here is our second big ASHRAE standard, ASHRAE 62.1. LEED says ASHRAE 62.1 gives us guidelines, and based on 1, the number of people in the building, and 2, the size of the building, this is the amount of cubic feet of fresh air per minute you have to bring in. It's a minimum fresh air ventilation requirement. And then there's another chapter, if you're naturally ventilating, how much to bring in and monitor that way. So that's our first prerequisite, guys. It's a fresh air ventilation requirement. Our second prerequisite in most building codes nowadays, no smoking in the building, within 25 feet of doors, operable windows, fresh air intakes, and if signage to say that's not allowed. If you do allow smoking in like a residential apartment building in the units, that's fine, but you have to weather strip the door to the hallway and put the hallway at positive pressure, so it's minimizing leakage into the common areas. And that is our final P we're going to see today. That's the last mandatory prerequisite in LEED. All the rest are credits. Here's our first one. It's called Enhanced Indoor Air Quality Strategies. Those grates or mats at every entrance, we've seen them before. The idea is scrape your feet off, get like salts and other contaminants from coming outside to in. Exhaust contaminated space, number 2. If you've ever been in your photocopier room or plotter rooms in an office, you know how stuffy they can get. So have a dedicated exhaust to get that air out before spreading into the common areas, 2. And MERV is a rating for a filter. The higher the MERV rated filter, the fresher the air is coming in. It's just a filter's rating. So you have to do all 3 for 1 point, and then another point for one of these 4. Model the air quality. Don't just tell me the whole building gets enough fresh air. I want to know each space individually gets enough fresh air too. And our energy models can show us. 2, increased ventilation. Bring in 30% more fresh air than ASHRAE 62.1. Whoa! That means you're going to be having to exhaust 30% more treated air. That's a third more fresh air to heat or cool, right? Remember a green roof? That had synergies. It helped 5 credits. This is a trade-off. It's going to hurt the energy credits. So what do? You can use an ERV, an HRV, a VAV. There's a ton of systems that recover energy. And the simplest ones are just like this. Think about it. Your hot air duct is getting exhausted. You can just wrap your fresh air duct around it, and you can recover some of that energy. But as I said, there are way more systems that do that a lot more efficiently in a lot of cool ways now. It's up to you. It's up to your model, your designer, what the owner wants in the building, how much money you got to spend. Balancing all the credits. That's a big part of the LEED consultant's job. Carbon dioxide monitors or alarms in case there's way too much fresh air or too little fresh air. Tell the building operator something's wrong and to fix it. The next credit is similar to materials and resources, and it's a very long list of standards. So essentially, any exposed supply we're using on our materials has a chemical a limit from a standard. So pretty much there's a very long list of standards here, guys. I would only like you to know these two, folks. Green Seal and South Coast Air Quality Management District are two VOC content limits for paints and adhesives. I would also like you to be aware of the green label, which is another one. You should also know the term formaldehyde. If you've never heard of that word, it's ugly, it's bad. Just remember it like that. We don't like formaldehyde in our products. And here's how I document it. So this is a pretty simple documentation. So why I think LEED has been adopted so much throughout all different industries is the following. Listen up, guys. The reason why developers and owners have bought in is the following. LEED buildings have higher occupancy rates than conventional buildings. The occupants and the tenants of LEED buildings, they stick around for longer and pay more on time. And the 08 financial crisis is a great example of it. If you look at the tenants and occupancy rates of a LEED building versus a conventional building, during financial hardship, the LEED buildings dropped. They dropped a lot less than a conventional building. I'll bet we'll see the same thing after the COVID. This shows me that LEED buildings attract higher quality tenants that can stick around and survive downturns in the economy, making your building more robust. LEED buildings appreciate faster, but the biggest kicker is they sell and rent for 2 up to 20% premiums than a conventional next door building just built to code. Tenants are willing to pay more money for a better built building that will be healthier for their occupants and that will pass through savings in sub-metering energy and water to themselves. So that is why developers and owners have adopted it so much. And then we, designers, builders, we use LEED as a tool to actually offer our special services to build these buildings for those owners. That's why we're needed. But then it's all the way down to the manufacturers and suppliers say, hey, pick me, pick my product. If you do, you can get this point or that point in LEED. And that's why LEED's been so successful, because it's such a tangible standard of defining what green is and what sustainability is, from the biggest building to the smallest product. That was good. All right, good stuff. I really like the financial elements to green buildings, because I think that it drives a lot of people to make changes. Anyway, another huge part about it, if you look at, I think Toronto, this has been the case for a while, but almost every major city on average, 30% of their new buildings are going for LEED last year. If you're a supplier of building products and supplies and you do not comply with standards like this, you are losing 30% of the market potentially. 30% of the market. That's crazy. That's what I meant when I said LEED was a market driver. It's changing the way how we do things all the way to the small suppliers for the better. Because if they don't stay up to date with the demands of the industry and the market, they're not going to be around. And it's up to us to increase that demand, to increase the sustainability of their procedures. Green Seal is important. Green Label is important. And then South Coast Air Quality Management District, or SCAQMD. Are the important ones. So we talked about the mess around the construction site. Have you been inside the building during construction? There you will find a bigger mess. And we follow, instead of the EPA's construction general permit for the erosion and sedimentation around the site, inside we follow the Sheet Metal Air Conditioning National Contractor Association, SMACNA's IAQ guidelines for the indoor construction. So this has some pretty simple things, like the HVAC ducts These are installed pretty early on, but they're not used until you're done. So cover him. Here we wrapped them up to make sure nothing flies in and contaminates it before they're even used. Scheduling. Know when our contaminating activities are happening and plan around it. Source control. Raise our materials. Protect their absorptive surfaces. And just general good pathway interruption and housekeeping. Any good half-decent construction manager or general contractor would do these anyway, but now you get a point for it. And guys, these are my pictures. Part of my job as a lead consultant is physically going on site and making sure that these were accomplished. And if I saw like a rip in the filter, I need to say, hey, general contractor, fix it, and go back. So that's how a lot of construction-based credits are shown. Okay. After you build the building, all finished, but people have not moved in yet. That's the frame of time when the air should, it's probably gonna be the freshest it's ever gonna be again. And you ensure that it's the case by flushing it out. A full building flush out just pumps fresh air through the entire building and gets any lingering contaminants up on out. That's the deal here. Now, on a major building, a big building, this could take weeks. Nobody is waiting weeks for a flush out. So the third option says you can test each space with an air quality monitor in your breathing zone on a grid, and only the spaces above a contaminant threshold you get flushed out. This credit's really only used for smaller buildings, in my experience. And that is all about like the breathability and the air. The second half of the category is all about the actual comfort. Look, if you're too hot or cold in the space, that's completely going to affect your level of comfort. ASHRAE 55 is our third big ASHRAE standard, and it says, I need the wall's insulation R value to be this good, and the HVAC overall efficiency to be this high. LEED says in ASHRAE 55, if your wall is tight, and then in combination with a good HVAC, your people are going to have a good chance at being comfortable inside. ASHRAE 55 is mandatory in more and more states under California Title 24 for years. But those are the three big ASHRAE standards. So just a quick recap. ASHRAE 90.1 is, do you guys remember what that was used for? Starts with an E, ends with energy. Yep, our energy baseline, good stuff. ASHRAE 62.1 was our ventilation rate, and 55 is for thermal comfort. And we'll recap them again later. Thermal control is also true. Your hot is probably different than my hot. So give me control, which is as easy as putting a thermostat in the space or an operable window as an option to control your temperature inside. With that, I want to control how much light I have in my building. Look at how easy this point is, lighting control. You can put a task light at everybody's cubicle and get it done. Easy. In a residential condo, we can see I'm tallying up my light switches and making sure I have enough on my electrical drawings to verify it meets it. Okay. Lighting quality is our next one. Lighting quality. Half of the credit is lighting control, and that's the easy point. There's another point for the actual quality of light here. I don't want too much direct overhead lighting glaring off our reflective surfaces. I don't want that light out today, this one next week, too much light there, too little here. How LEED defines a high quality of light is when you have a consistent amount of light in the space using long-lasting bulbs. And the whole goal is to mimic soft, natural daylight. Okay, that is the goal here. And this is a new option in version 4, and you usually need a pretty good lighting designer for it. So I mentioned the word daylight, and that is one of my favorite parts of a building. It really changes my mood and my behavior if it's done right. Think about this statistic. Listen up, guys. If you had a PV panel on the roof of your building and it's generating energy from the sun right now, and you use that energy to light up a light bulb, you are taking light to light energy at a 5% transmission rate, efficiency rate. Whereas a window is light coming in at, I don't know, 100%, right? But glass, oh, wonderful glass. Feel the window and then feel the wall beside it on a cold evening. Tell me what's colder. I'll bet you the glass window is. Glass is the absolute worst insulator we could ever choose to build our buildings with. If you've seen Toronto's skyline, you can see the ugliest skyline, in my opinion, in the world. A bunch of glass boxes. We've gone through a building boom the last 15 years, and unfortunately the fad is glass. Floor to ceiling, wall to wall, corner to corner glass. What are you doing? Why are we building like this? It's crazy. Simple architects love it because it gives us wide, pretty panoramic views, which even our feet need to be able to see all day for some reason. But the real reason is glass is the cheapest building material. It is cheap, it is light, and it is easy to throw up a curtain wall of straight glass. You don't need a lot of skilled labor just to throw up a curtain wall of glass. But as an insulator, it is the absolute worst thing we could use. This is why your model and your design is so important. Figuring out what type of window is right for what facade and at what window to wall ratio. So you're still getting enough daylight to offset artificial lighting needs during the daytime, but you're also maintaining the integrity of the envelope's insulating property. That balance between daylight and insulation is what's the basis of building science, and in the glass obsessed society, we have totally forgotten about it, and we are going to pay for it if not already. On a lighter note, that's funny. Energy models have gotten really good at simulating daylight. So they've gotten really good at showing us without building the building how the sun will illuminate certain areas. Or you can actually use one of these devices to physically measure it, okay? When daylight's done right, I think it really makes a space. The next one is views. Look, if I'm stuck inside for 90% of my life, at least give me a connection to the outdoors where I want to be on a nice day. At least let me see it. So I only care about regularly occupied space though. Like I don't care if there's a view in the bathroom or mechanical room. I want a view here where I'm actually spending my time in a classroom, let's say. But I only care about regularly occupied space, as I said, and I actually care what I look at. So no longer does a brick wall 3 feet away like everywhere in Manhattan looks onto count. I don't want to see a brick wall all day. I want to see people, activity, nature, the sky, things you actually want to enjoy and see. And the way you prove this one is you imagine yourself in the whole floor plan, and if you have a direct line of sight to the outdoors and what you're looking at. Which everywhere has in this glass box in Toronto I worked on, except for that interior boardroom over there. No exterior walls. And to answer your question, Steve, I've been waiting 10 minutes. Finally, acoustical performance. There you go. I know you mentioned it earlier. This used to only be in schools, and now it's in every adaptation. Look, really relevant to this usually classroom. I want you to be able to hear me. Like this is a knowledge. You got to hear this knowledge, or you're not going to absorb it at all. I don't want to hear the HVAC buzzing. I don't want to hear my voice bouncing off the walls or you whispering. I ask surfaces to at least be coated with a high noise reduction coefficient. That's what it's called. So it absorbs sound instead of reverberating it back. In offices, namely open office concepts, I've often seen some noise maskers or noise generators with white noise generators try to be used in some floors or ceilings. They work 50% of the time I've seen them, but I think they're getting a little bit better. And believe it or not, everybody, we just went through 100 points. You got them? Usually in live ones, there's a big laugh at this point, which I never got, but you got them now. As I mentioned, it's all recorded, so you're gonna see it. We're not done yet though. We still have our 10 bonus points and then are talking about the actual exam. Now, I think there's a couple people here that I might have not added to my my attendance list. So if you did not get a text or an email from me, if you got one of them, you're on my list. But if you didn't get a text from me or an email from me this morning with the materials or just like my reminder, please message me in the chat what your email address is, because I need to make sure you're on it so I can email you the follow-up stuff, okay? So again, if you did not get a text from me or an email from me this morning, please type it in the chat. Okay, so before our 10 bonus points, something I'd like to share with you are passive techniques, because these are often overlooked, especially in the Northeast climate where it seems like fall and spring are literally 3 days long. But if we were going to try to cool off a building in a warmer temperature, where would the cold air come from? We always bring it in through the north facade of the building. That's the cold side. And we duct it out the hot south side. Look at the sun, guys. In the summer, it shines on a high southern angle. In the winter, it's at a low winter tilt. So have these overhangs like you've probably seen in real life to block the unwanted high summer sun's heat from getting in. But give me free solar heat gain. I want that free heating from the low winter sun. Don't have too much western windows. Guys, when the sun rises in the east, it heats up our building, heats up our building, heats up our building. Setting in the west, even buildings in Toronto in the dead of winter turn on air conditioners because they get too hot because there's too much western facing glazing. Brutal, crazy. Sun shines in the same place every day from what I can tell when I wake up. Let's take it into account when we design. Like, these are passive techniques. There's hardly any moving parts or energy used. Let's try to employ parts of them if we can. All righty, everybody, on to our 10 bonus points. The first of 4 are in innovation and design, and there are a total of 4 ways to get a max of 6 points. Okay, that's how this one works. 4 ways to get 6 points total. And the first one is called innovative performance. And this is when you do something. Sorry, guys, 1 second. I'm just trying to get this off my screen. That is when you do something that is good for the economy, environment, and or society. So you're meeting the triple bottom line, but you're not getting any points for it. I'm like, hey, this is good what I'm doing. I should get a point for it. So you can actually make up your own credit. And that's what we're looking at here. So in this example, green cleaning, I know we've had some ones in the chat about like green space and these newer ideas that, you know, might not be applicable to everybody or are too difficult to be in the mainstream rating system, but this is where you can get rewarded for doing something special. And this one is one we use. It's not that special, but it got an extra point. So green cleaning. Give it an intent. We're trying to minimize the amount of harmful chemicals used throughout the life of the building for janitorial and custodial services. Is that good? Sure. Did we talk about it? No. It's a benefit outside of the scope over here somewhere, but it's still a benefit to the triple bottom line. So give it a requirement. Here we say 50% of our cleaning agents have to meet EPA's clean product standard with a chemical content below X. So like a real credit, this one is quantifiable. We're able to measure its merit in some capacity. That's one. It has to be comprehensive and transferable and repeatable. Okay? You can be as creative as you want with these, right? They can always just say no to you, but they're usually pretty good about it. One that I love to see, especially on university campuses, is using a dashboard like this. So these dashboards tell you all the information about how the energy systems work, educating the tenant, because if they can see where they're using or wasting energy and water, they're going to start to conserve. They can always say no to these, but they're usually pretty accommodating. And there's this is the best website on the internet. the Green Building Information Gateway. Every green building on the planet is shown and described here. And then the USGBC has good examples of all the LEED buildings. Yeah, so yeah, the United States Green Building Council has a lot of good examples, and the Canadian Green Building Council does too. Okay, that's our first one, guys. Yeah, so the Green Building Information, sorry, who assesses these? It's the GBCI, the Green Business Certification Inc., the one that review everything. They review these credits as well. So that's the first one. The second one is the pilot credits. So these are the new credits, but how are we going to know if they work or not? And if we should use them in version 5 or whatever? I need somebody, and I'm going to incentivize a project team to hop in the pilot credit library, pick one out, and try it on their building. Even if it doesn't work, as long as you're giving me good feedback, I can iteratively improve it before the new version comes out. So test a pilot credit out for me. You get a point. And the third one is exemplary performance. Remember the little Y in the bottom right corner? That Y is if there's a bonus option. So LEED says if you are 55% or more water efficient, or 54% or more energy efficient, if you beat the highest rewarded threshold, I'll give you a bonus point for going above and beyond. Not every credit has that though. Like think about sensitive land protection. You're either on a farmland or you're not, right? That's like a black and white yes and no credit. So only some of the credits have this bonus option. And lastly, the LEED AP. So if there's 5 of me on the project, how many points do you get? Just 1, unfortunately, but it would be a great team, right? Thanks. It's pretty much a giveaway point. Obviously, there's a LEED AP somewhere working on the LEED project. Usually it's the LEED consultant designated for this point. The new thing in version 4, though, is your AP type and specialty has to line up with the building type. So I'm an AP, BD, and C, and an O&M. So I'm only worth a point on a new build and an existing building. That's me. I'm not worth a point on a neighbor development because I haven't taken that exam. And those are 4 ways to get 6 points total in innovation and design. And the last 4 points to round us all out are regional priority. And this is relatively new, but it makes a ton of sense. A building where I'm at in Toronto does not have the same credit priorities as a building in LA. Let's take Los Angeles for an example. LA, the most important stuff right now is water's been important for the last while. So the local USGBC chapter in Southern California, all the members voted on the 6 important credits there, and the water were a part of them. So each of those water credits get an extra point tacked onto it. So if I register my project in LA and I get that water credit, I automatically get an extra point for doing it. So what this does is it just increases the weight of 6 credits so that people will be more likely to do it if I see an extra point up for grabs. That's the idea. Each region has 6 of these 6 of these selected rather, but even if you comply with all 6, it's a max of 4 extra points to get. And you can look yours or anywhere's up here on that link. And those are the 10 bonus points. How are we doing? Lots of thumbs up. Excellent. Credit interpretation ruling requests. So this is just a few things that if they come up, I don't want you to freak out. I've seen them come up before. If you're working on a building and you're like, I'm in a unique situation. Is this going to work for this point? Where do you turn to for the answer? First off, go to the reference guide, comb through those pages. Can't find it? Okay, call up USGBC's customer service. Try there, wait on hold for too long, throw your phone away. Then submit a CIR, a credit interpretation ruling request. This is a mouthful for a formal inquiry. It just says, hey, LEED, this is what I'm trying to do. This is why it's unique. Will it work for this credit? And they'll say yes or no and why. Look, you're going to save a lot of time and money if they say what I'm going to do is not going to work. So I'll stop right there and change it or not do it. They're not precedent setting though, which means if they said yes to me, does not guarantee they'll say yes to you, just because I might be in a very one-off, unique situation. Anyway, it's just a question. Or alternatively, you can submit a suggested approach, which is when you do something that is not explicitly in the reference guide, but amounts to the same good of an existing credit intent. Well, what do I mean? So a good example, in Toronto, this building I worked on was just outside the half-mile distance to a subway stop. And we were sitting there like, oh man, that is 6 points I'm leaving on the table. So we said, you know what, we're gonna make up our own approach. We put 5 hybrid zip cars, like the auto share car-to-go vehicles, in our lot, specified for our building's occupants to share. And we wrote a long narrative. We said, hey, LEED, this is a different way, if you think about it, to discourage people from buying their own gas-powered cars driving alone. I'm giving them some hybrids to share. And they said, you're right. Here's 2 out of the 6 points. So they were reasonable. So why was that not an innovative performance point? Because we talked about transportation. There were 4 credits on it. This is a different way to get that credit, whereas green cleaning was a whole new idea outside of the scope. This is just a different way to get an existing credit, and they can also say no to these 2. AIA stands for American Institute of Architects. We talked about LEED alternative compliance paths. In Canada, we can use ASHRAE or NECB. In China and India, in the Middle East, they have their own equivalent standards. But for the exam, only the American standards are to be known. LEED interpretations are precedent-setting answers to our tough questions, which means if they said yes to me, they'll say yes to you automatically. You don't need to ask it again. It sets the rule, precedent setting, and you can just look in the LEED addenda. Like any addendum, LEED has quarterly corrections and clarifications to the reference guide. And who makes those up and answers our questions? It's the TAGs, the technical advisory groups. They are the industry leaders, academics. They're the ones answering our tough questions to make our LEED interpretations and making up the pilot credits. They're determining where the new versions of LEED are going to go. Okay, guys, that's all the info for today. Now on to the exam. It's 2 hours of fun. It is 100 multiple choice questions. A perfect score on the exam is 200. Listen, if you walk into the exam, sign your name, and walk right out, you automatically get 125. The magical number, everybody, is 170. However, if you get 171 or 199, there's only one person who cares on the planet. You're looking at him, everybody. You can brag to me about it, but that's about it. A pass is a pass, 170 and up. Listen, obviously 170 out of 200 is not 85% like math says it is if the lowest you can get is 125, because the scoring scheme makes no sense. Some of the questions are worth 1 point, others are worth 2, some are even worth 3 points. Each exam has 15 questions worth no points, and they're just there to see how you do on them and if they should be used in future versions of the exam. But we do not know which question is worth what, so you never ever think about this again, please. Most, if not all, questions are going to be choose 1 of 4 or 1 of 5. There might be a couple questions that are asking you for choose 2 or choose 3, but they'll always tell you if they want you to choose 2 or 3. And if you only get 1 of the 3 answers correct, no part points. It has to be all correct. There are no points off for getting a question wrong, so don't you dare leave anything blank. And all I'm trying to say, everybody, is there is absolutely no strategy to taking this exam. Thanks for coming. No, honestly, guys, the scoring system makes absolutely no sense. There's only one way to approach this thing. Take it slow, do 1 question at a time, and just get each question right. Okay, just get them all right, you'll be fine. I know it sounds ridiculous, but it's a lot nicer than these other exams we're used to like overthinking in college and university, being like, oh, there's more points over there. I'll lose points there if I get that wrong. Should I spend more time? That's my weak area. There is nothing like that to think about. This is the approach everybody needs to take, and it's the one that gets success. You focus on that one question at a time, and you do your best to get the right answer. Forget everything else. You zone in on that question and just do your best to get it right. Okay? That's it. That's your approach. It's a multiple choice exam, and the only time that makes it a little more difficult, as we know, is when you can sway A, but also make the argument for B. But by the time you go and take the real thing, you'll have done my 400 practice questions, and you'll start to get a feeling of, yeah, I know when it could be A or B, but A is what they're trying to test my knowledge on, and that feeling will come over time. The biggest issue my students have on the exam is time. So as I said, it's 2 hours. There is a clock. Time is my students' biggest issue. So as I just said, you'll have done my 4 practice exams. Listen up, everybody. 4 practice exams before you go and take the real thing. You'll be pumping my practice exams out in like 30 or 40 minutes tops. You have 2 hours for this thing. Please slow down on the real exam. All my students make the same mistakes, and they were the ones I was making, the easy and silly ones. Each exam, they have like 3 questions out of the 100 that are worded super weird and awkwardly. I don't know why they've done it. I asked them to stop. You'll see what I mean when they come up. When you get to those, take a breath, slow down, step back, and just reread them, digest them, reread them. And once you can gather what they're actually asking, they're not too hard to answer. Don't miss a question if it has the word not in it. You'll get it wrong. Don't miss if it asks you to choose 2, which it always will tell you if that's the case. As I said again, time is a non-factor, so please slow down. Okay, so listen closely. Now, I'm going to tell you how things work normally. Normally, these exams are taken at prometric centers. Anyone been to one of those fun places? Yeah, we got GREs, GMATs, fun stuff, FEs. So these centers are in every major city. Most university towns have them as well. The exam normally is very convenient. It is offered 6 days a week, evenings included, and you book it after you've studied and hit my steps, which we'll talk about. You book it like a week or 2 in advance, and you show up and knock it out, okay? So I'm going to do normally first. So as I said, they're usually really open. Now, again, this is April 2020. Right now, pretty much every prometric center is closed, obviously. What we started to see is in other countries, as they slowly have reopened, they've also opened the prometric centers, and they're social distancing inside and only doing every few chairs and whatnot, and slowly reopening. With that said, I'm a USGBC faculty, so I'm constantly in talks with USGBC. Prometric has a pro-proctor tool, which you could possibly take the exam at home online. Now, it's only, although it seems like it's been a year, it's only been a month since the prometric centers have closed. So I'm trying to get that finalized, because it'd be awesome if everybody could take it at home online, however the proctored system is. However, if that doesn't go through, and I'm hoping it does, the prometric centers will eventually open, as will the world. You'll have access to these recordings and this materials if you signed up during this crisis for as long as you need. I'm not trying to rush anybody or put anybody in harm's way. You'll have access to me and my materials for as long as you need. And please just keep an eye out for an email from me once that online ability is finalized. If it is, I'll be the first one to tell you, okay? But for now, you still need to study anyway. Okay, so normally what happens is you walk into these centers, someone's doing their GRE there, their GMAT there, they're freaking out, and you calm down, because our life really doesn't ride on this thing at all. You take a seat at your computer, and there's like this 15-minute tutorial pretty much telling you like how to use a mouse. I think we know how to do that. Don't skip the tutorial though. I use those 15 minutes, and so should you. When you get to your desk, there's a blank piece of paper waiting for you and a pen. And so look, I had a tough time with a few things when I was studying. I just couldn't memorize them. I couldn't remember them. It happens to all of us. So right before I walked into the exam, I read all that stuff I couldn't remember. I put it in my locker. I sat down and quickly scribbled it down on my blank piece of paper. You should do the same thing. I made a little cheat sheet off the stuff that I had just read before I walked in. I didn't end up using it, but it was there if I needed it. This is the interface of the exam. So if the first 5 questions as an example are impossible, please don't sit there and stare at them for 10 minutes. Mark them and get on with it. As they marinate somewhere back here in your subconscious, I can bet some future questions might answer it for you or help you trigger something. Because to answer your question, Katrina, at any point, you can hit review and hop back and forth, change answers up, change questions up. There's no order you have to do it in, is what I'm trying to get at. Okay? And I'll show you a tutorial after class, exactly how to register for the exam, get your student discount. I've had some questions of people like being recent graduates. If your graduation date, you can put that in the fall, especially for now during COVID. As long as you have a student number or a student ID, you'll be able to get that student discount, and I'll show you where to put it on my tutorial. Okay, you do not need the calculator. That's for the AP. You can comment on questions when they're silly questions. I tell them they are. I'm sure they read them. And when you're done, as I said, you just hit review. You hit complete. They say, are you sure? I say, yes, I'm sure. And then it spits your score back right then and there. And you quickly text me and tell me, Lauren, I passed with this score. You're the best. But actually, please text me or email me when you pass. I rely on you guys. Any feedback on things that were stressed on the exam that I didn't stress, that's how I constantly improve this course. Also, this is my 4th webinar ever, and so I do hope that you will give me some feedback about this. I think I've kept you pretty engaged. I know there's some boring ones that are like voiceovers. I can't imagine your older profs, for those in university, trying to use this technology right now without help, but hopefully this was a breath of fresh air to the remote life we're living right now. Trying my best. So the next, any questions about the actual exam? Yeah, so you can take the exam, Ian, whenever you need to. So the exam is offered in normal circumstances 6 or 7 days a week, whenever you're near a Prometric Center, and I show you in a tutorial how to find it. You'll have my materials. I usually give my materials access for a year anyway, but like if you need it for longer, I'm gonna extend it for as long as you need. You'll just email me. Okay, listen up, guys. We got some really important stuff. So if you really have to go somewhere, please don't leave until 7:15. Thank you guys for sticking around, though, by the way. This has been good. Study time, 40 hours, everybody will pass. That makes no sense. I don't know why people say that out there. We all have different levels of knowledge, experience, and study habits. Like, 40 hours doesn't fit all. It's so subjective. It doesn't make any sense. So instead of that, I give you 3 steps to success. Listen up, everybody. Number 1, guys, take the workshop. Good job. 2, you got to read my study guide. I know how much information I just delivered. I know it came fast, and a lot of it or some of it is brand new. You need to get through my study guide. It's not too long. It'll reiterate everything you need to know. And there's parts of this class that you probably think you got and you don't fully grasp, and this will just reassure you you understand it completely. That's step 2. Step 3 are my best 4 practice exams. They're very realistic. Now, on the real exam, mine might seem a little harder or a lot harder. I'd rather you be a little over-prepared than the reverse. And only when you get 85% on my 4 practice exams, and you can redo them as much as you want, that's when you know you're ready to go. They mix up the questions and the answers. You need to get 85% on all 4 practice exams and read the study guide if you want to pass. Because everybody who's followed those 3 steps that I just mentioned has passed, and so will you. Okay, and I'll show you where to get everything in just a moment. Okay. Now, a lot of people have asked me about the AP, especially as some people's work gets less and less busy, or work gets non-existent, or school starts to wind down. A lot of people are going to be finding themselves with a lot of time on their hands, I think, and people have reached out. Now, the AP. So I've been getting a lot of questions about the AP level 2. What I have to say, if you know you're going to get the AP eventually, I say to get it out of the way now. Now, I'm not trying to pressure anybody into doing this. A lot of people, the Green Associate is more than enough for their industry. But if you know you're going to do the AP, I do encourage people to do it combined with the Green Associate. Now, the first AP you do is the BD&C. No matter what industry you're in, that's the one that's the most useful today, most in demand today. And it encompasses elements of the other 4. Then you specialize more down the road, like I did with O&M when I started doing some existing building projects. Also, between the Green Associate, what we did today, and the BD&C, there's a ton of overlap. The Green Associate is based on the BD&C rating system for new buildings. So there's a ton of overlap. And that's why I did them combined 10 years ago. I did 2 hours for the Green Associate, 20-minute break, 2 hour for the AP BD&C. I knocked them out in one go, and I was good to go forever. That's what I did personally. Now, the AP, until a couple of years ago, required actual LEED work experience, which never made much sense. Like, remember what mine was? It was an RV waste station, or nothing. It didn't help me on the exam at all. So now they got rid of that requirement, and some of the questions inside are these experiential-based knowledge questions. But I've been teaching the AP class for 7 years now. I've always given you exposure to one of my sample projects, and it makes those questions a piece of cake. The biggest difference is the leap in the level of knowledge you need to know. You need to understand the points for credit, the percentage thresholds, the detailed calculations, the whole lot. However, you've got to know parts of the reference guide, which is a $300 monster document. I do include the reference guide in this workshop if you're interested in the AP. I've also summarized it into these 40 11x17 charts that tell you exactly what you need to know in every single credit, so you don't have to read the reference guide, which took me forever. And the 4 practice exams, a very similar style. I'm going to email you guys, and if there's enough demand for an AP webinar, I might do one like this. But normally, most people just do it online on demand. There's a lot of detail, so the ability to pause and rewind it and go through it at your own pace has been helpful. And it's a little more expensive at that $400, but I'll be emailing you a $100 coupon code if you're interested in the AP workshop. Any question about the AP? Okay, everybody. So what we're about to do now is I'm just going to show you where to get all of our materials. So what I'm about to go through is going to be explained in an email way better. So please just look at me up here as we go through this, okay? Everybody just follow me. All right, so you're going to hit login. Now, pretty much everybody here has a login. I think there's a couple of people that haven't paid yet. You got to pay by the end of the day, please. If you're here and you haven't paid, please go on the website, leadinggreen.com/online. Most of you have a login already made. Now, you can use that login to access the materials. However, if it doesn't work, everybody, I'm going to be emailing you guys a new login. Whoop. I'll just use my own. I'm going to be emailing you guys a new login that you can use for a year or more. That is your login. There's a specific amount of people that are allowed to use it, and I know it, so please do not share with it. You could disable the account. So you're going to log in, all right? Also, I forgot to mention, if you do know anybody, I am having a few more webinars. I'm trying to do them twice a month. you know, it's a tough time for everybody. I'd really appreciate your help getting the word out. This kind of makes my life feel a little bit normal, being able to see you guys and interact with you guys. So I would appreciate you guys spreading the word here. So after you log in with your own login or the one I emailed you, you're going to hit LeadGA webinar or LeadGA in class. So this will take you to this paid webinar. And now with either the login you created when you registered or the login that I'm emailing you, you'll be able to access everything on this page. Sorry, this website is being so fast right now. Hello. So there's going to be a few. So here we are. Okay, so we just did the webinar. You have the slides, right? We just did that. That's step one. This is the Green Associate Study Guide. That's step 2, which you need to download. And then we go through the 4 practice exams, do them until you get 85%, go back to the study guide, back to the exam, back to the recordings, and then here's step 4, a tutorial on how to register for the actual exam. So that is all going to be in one place. If you don't have a login that works, I'm going to be emailing you one. Okay, so here's the study guide. Oh my goodness, 100 pages. It's honestly a picture book, folks. You got to get through it once. Look at all these pictures, amazing. Page 80, we're already done. That was fast, right? Now, you got to read it, please. It's not too much. It's written really lightly. It'll really reiterate what we learned. By page 80, we're done. Here we see my exam tips that I just went through. Here are all the references and figures. If you care where I got my stuff, go nuts. This is a massive chart of every single standard that LEED has ever piggybacked off of or used. You do not need to know them. You do need to know the biggies, the EPA Act, the ASHRAEs, the ones that I dwelled on. That's coming up, and I reiterate them in my practice exams in my textbook. But if you're interested in a specific credit based on your level of background or interest, check it out here, and this is where its foundation lies. And I told you there's going to be a few questions on refrigerants. Here are the answers. Read this document a couple times. Know what a CFC is, why it's banned, what year, what protocol. Makes those questions a piece of cake. Okay? And then when you think you know your stuff, onto my practice exams. There's 4 of them. You can do them as much as you want. Here we go. That one, oh, too bad. That one. Oh, there we go. Sometimes you get a question right for a completely wrong reason, like that random guess you just saw. If that happens, if you get it right or you get it wrong, I need you to read the explanation. A lot of times, and I did this too, and it's dangerous, I got a question right for the totally wrong reason. If that happens to you, and they change the wording just a little on the real exam, and you have the wrong idea, you're not going to get it right on the real exam. You need to read the explanations, whether you get it right or wrong. Not only do I tell you why it's right, I tell you why an option might be wrong and what it's subsequently right for. So it's like you're testing and studying at the same time. And then once you're getting that 85%, you're ready to go, you're done, move on, knock out the exam. You need to be smart with your studying. If you are noticing you're getting the water questions wrong, stop. Don't try to memorize them. Good luck doing it anyway. Re-watch the water section. Reread the water section. Email me. I am here. Call me. I am so happy to help folks. Guys, to be honest, the real reason I made this workshop, and I'm still doing it, is when I was in your shoes 10 years ago, I spent so much money and so much time. The materials out there that I found were broad and expensive. And after I passed, I said, I could have done this in a quarter of the amount of time, spending a quarter of the amount. This is the fastest way. Use my materials. They really focus on what you need to know for the exam and more if you need to, but I narrow it down. And it's definitely the most cost-effective way to get it done. So just follow my steps, do your best. And once you hit that 85%, you'll be ready to go. My next workshop, I think it's going to be May 9th probably, or April 29th. If you can spread the word again, I'd really appreciate it. I constantly update it. I'm adding more and more as we get it stuck inside longer and longer. I think it's a good opportunity to get involved. So I'm going to email everybody a new login and instructions that I just went through for you to have in writing. If you don't see that in your email by tomorrow, it is in your spam folder. If you still don't see it, email me and I'll send it again, or just text me. Okay, guys, what we're gonna do now, thank you guys for sticking around. This is awesome. I do appreciate it. What we're gonna do now is that 25 question practice exam. So you guys could all download that from leadinggreen.com/slides. This is what we're doing together right now, this in-class 25 question practice exam. I would love it for all of you guys to stay if you don't have somewhere to go. We'll be done by 7:40. We'll be done in 20 minutes. I'm just gonna give you guys, 10, 15 minutes to try to do this on your own. Do your best, like don't use your materials, just try to logic it out, read them carefully. And then I'm just gonna talk you through them one at a time and just tell you how you got them, if you got them right or wrong. So I'm gonna post this in our little chat here, send it to all. If you still need to pay, please pay at leadinggreen.com/online. This is the 25 question practice exam. Try it yourself for 10 minutes and then we'll talk them through. Okay. So if you can stick around, please do. And we'll be done at 8:40. Okay, guys. Now is a good time. If you have questions, now is a great time if you want to ask it in the chat. And we can talk about it after the class if we need. Okay, guys. Good luck. I'm just gonna read these questions like I wanted you guys to read them and then focus on what, oops. And then focus on what I wanted you guys to focus on. I'm gonna pull up the answer key, 1 second. So for LEED product experience, just to answer your question, Shara, you don't need any LEED product experience anymore. That was a requirement about 4 years ago to take the AP. Now all you need to do is just have a course and be prepared for the actual exam. Okay. So here are the answers. Now, I would much rather you just listen to me go through them one at a time as I do. If you don't hear a particular answer, then you can look at the, then you can look here as I have the answers up. Okie dokie. Oh, just to get experience for knowledge purpose, I do connect people with some volunteer opportunities, but I also would encourage you guys to check out your local U.S. Green Building Council or Canadian Green Building Council chapters, as they also have some opportunities that come up. Also, in the email following up, I ask everybody if you want to send me your resume. A lot of employers come to me when they have openings in the industry, and I always forward it off to you if you're in that region. I keep track of everybody just to let you know some opportunities that do come up. So do feel free to share your resume with me, and no problem at all. All right, guys. So I'm going to do these pretty quickly. So if you don't hear me, just take a look over here. So the first one says, which category asks us to locate near development these strain sites and in diverse uses and in dense areas? And you just got to know when it's asking for the category or just a credit. This is the whole category, which is location and transportation is the answer. That's the category. 2, what workshop helps us set goals and objectives? There's only one workshop here we talked about today, and that is the LEED charrette. The rest of them are made up, so they're probably wrong. Indeed, they are wrong. Our third one says, what credits would be impacted if we had our PV panels shading that parking lot and using that electricity for EV charging stations? We had that example today in class, in fact. The heat island effect, 1, because of the shading, and 2, the green vehicles credit because of those EV charging stations. That's A and B. 4, Our next one is all about the EPA Act. If we remember, that was our baseline for our water use reduction. And we did a little Excel calculation chart there on the water slide for indoor water use reduction. C. 5, site assessments got to include 3 things that are physically actually a part of the site. And there's only 3 that are actually on the site here, which is going to be the geology, if there's an existing physical structure, or any hydrology and vegetation. C, D, E are actual describable parts of the site. 6, difference between RECs and carbon offsets. I mentioned briefly that RECs are tradable commodities. If you didn't hear me say that in class, now you did. And we drew a picture of how you're kind of trading money for energy to simplify it. RECs are tradable commodities. 7, listen up, keep in line with me, please. We're on 7. We're trying to have a 9-story residential project compared to a baseline, and there's only one baseline we talked about of these options, and that was our energy baseline, known as ASHRAE 90.1. 8, how should we select our materials? When it's a very general question like this, I ask you to go back to the most general idea we had today, which was a triple bottom line: the people, planet, profit, the environmental impact, the social impact, and the cost, DEF. How should we compare the environmental attributes of products? To go to the next step, life cycle assessment is the best way to do so. Life cycle assessment is the answer I'm looking for here. Okie dokie. 10. If we remember, it was a lot, not that long ago. How long do we spend indoors? 90% in normal times. So get outside sometimes, maybe not right now. 11, the TD office towers. These are Sonic Mills Metro buildings in downtown. $110 million retrofit to get LEED Platinum certified. And one of the biggest things in that project was replacing their single pane windows from the 50s with dual glazed argon-filled glass, decreasing the overall energy demand of the building, E. Now listen, why D, energy efficiency, is not right? The term efficiency we use for active systems. So lighting and HVAC go up or down in efficiency. That's what we refer to as an efficiency. A passive improvement, like a better insulating window or wall, leaks less energy out throughout the year, which decreases the overall demand of the building. So active improvements for like HVAC and lighting go up or down in efficiency. Passive improvements decrease demand, like a better window. C, thermal control is also not right. Thermal control is achieved with thermostats and operable windows in LEED. If it said thermal comfort, that would be right, but it doesn't. 12, name a distinction between green and convention design buildings. Green buildings have got to use that integrated design process. They don't necessarily cost more, like it says in B. Usually it costs more initially, but doesn't have to. But it also costs less ongoing, and B doesn't refer to what part of the project, so we can't assume it's just the beginning. Okay. $13 sterling only cares about the economic return. Why would even he go for LEED? Because statistically they rent and sell for 2 up to 20% more than comparable counterparts. D isn't right. It says guaranteed incentives in all jurisdictions. How I wish all jurisdictions had green building incentives. My life would be a lot easier. Maybe next year. One thing I forgot to mention, one thing that's getting much more popular and really important is something called energy benchmarking. So cities are making, like Toronto, New York, they're making you rank your building's energy performance amongst the whole lot of your same class of buildings. And eventually what's going to happen, and it already is in New York, if you're in like the bottom 10% performing of buildings, they're saying by 2030, if you don't improve it and don't make these changes, we're going to ding you with this huge penalty. So it makes my life a lot easier because I'm like, hey, building owner, you can put in X amount of money and save and probably pay it back in 2 or 3 years, or you can just not put X amount of money, and then at 2030 you're going to get dinged and you're going to be forced to do it, or it just won't economically make sense. So energy benchmarking is getting a little more popular, which I like to share with you in this class. Anyway, 14, what do we submit on LEED Online? This was a long time ago. Credit forms. Credit forms was the correct answer, and it is the checklist to make sure you have all the right documentation when you submit your credit requirements on LEED Online. What's true about an innovative or performance credit? It's got to include a quantifiable benefit out of the scope of LEED. Our example was green cleaning. We just had it in the first innovative performance, innovation and design credit. Natural ventilation is gonna definitely affect a couple categories. It's gonna affect the amount of fresh air coming into the building. That's indoor environmental quality we talked about, and energy and atmosphere, hopefully saving some energy by naturally ventilating. A and C. 17, how can a team reduce energy and waste associated with demolition? Ooh, that's familiar. In fact, that is the intent of MRC1, which was building life cycle impact reduction. And the answer here is actually just the first 3 options from that credit, which was to reuse a historic project, select an abandoned or blighted building, similar thing, or restore an existing building. D, E, F were options 1, 2, and 3 from 17. 18, anybody remember the carbon dioxide from buildings? It was a long time ago, I know. 38%. 72% was around the electrical consumption, and up to 50% was the energy, which includes natural gas. Around those numbers, I like you to know about US building consumption that LEED likes to refer to. 19, lots of ways to fight damages caused by refrigerants. This is not one of them. Long atmospheric lives means high ODPs like Freon. We don't like that. Don't miss the word not, please. You'll get it wrong. FTEs, that stood for full-time equivalents, or how many people are in the building. And we use FTEs when we calculated, remember I wrote 200 FTEs and we used that for our indoor water use reduction. That's number 1. And number 2 is bike parking and showers. The amount of bike parking and showers is a function of how many people are actually going to be expected in the building. E is not right. If you give people 1 toilet or a lot of toilets, it's not going to change how many times people go to the toilet. We care about the flush rate of the toilet, not the physical number of them. That's like code tells you that. 21, here's a toughie. We're trying to use less potable water. That's familiar. In fact, that is the intent of the whole water efficiency category. And I know that gray water for non-potable needs, like in my toilets, that's a good way of reducing potable use. Water efficient fixtures for sure. And only use native plants, you hardly, if at all, need to irrigate them. Those are the best 3 ways. Submetering might reduce water use, but it's not guaranteed. So that's why D isn't right. And I'm sure a lot of you put F probably. F, capturing, treating stormwater. So the reason why you got tripped up on that is because you do get points for doing that. But those points are in sustainable sites, rainwater management. It has nothing to do with using less potable water. It would have to say you captured the rainwater and then also reused it in your toilet. The treat is just to confuse you, because you can treat stormwater by running it through the ground and naturally treating it into the aquifer. So that's why F isn't wrong. It gets you rainwater points, but not points here, which trips people up a lot. Quality open space is not the result of open grid pavement. Open grid pavement is good for rain, and it's good for the heat-on effect, but it's not gonna get you out there to use it, like a walking path to a courtyard is, or a community garden is, as examples we had today in class. 23, what area is optimal for a LEED project? High development density, build up, not out, build where there are buildings, big theme in LEED. 24, listen to this one. We're trying to maximize its floor, the building's floor up to area ratio. That's one good thing. And also minimize rainwater runoff. That's 2 good things, period. Which of the following demonstrates systems thinking? So this is a terribly mean question. You should have ignored the first sentence. It has nothing to do with what's being asked, which is what demonstrates systems thinking, which essentially is how the building fits in to the area around you, like in the middle of nowhere or downtown. My example was like, is there a road? How will occupants travel to the project is an example of the systems thinking approach. Anyone get that right? No, you got, well, a couple people got. You'll never get a question like that in real life. As I said, that's terribly mean. But now you're going to read every question for the rest of your life, even more carefully. So you're welcome. But don't worry about that one. That's awful. And 25 leads a nonprofit organization ensuring fairness and credibility by being a C, consensus-based process. So these 25 questions are more or less straight out of the 400 online. Um, don't worry about how you did on them. You'll see them again when you actually read the textbook, and you'll be more prepared for them. When you are studying, please, as I said, don't hesitate. Reach out to me. I am here and happy to help in any way. Whether it's questions about the Green Associate, the AP, or the industry in general, hit me up. I'm so happy to help. Thank you guys. I know we went way late, but I tried to go in a little more detail and make it a little more fun, try out some new jokes. So I appreciate you guys for sticking around this long. Now, if you do have any questions that come up, email me, as I said. Otherwise, look out for the email from me tonight or tomorrow with the new login and all the instructions. And as I said, I'm here to help, guys. So thank you for coming, everybody. And that is all for today. Stay safe out there. We'll all get through it. We're all on it together, as has been drummed into my ear. And that's all, guys. Thank you.